Carl Sagan could not have predicted 2021, but he did see it coming. He wrote the following back in 1995, and we quote, "I have a foreboding of an America in my children's or grandchildren's time when the United States is a service and information economy, when nearly all the manufacturing industries have slipped away to other countries, when awesome technological powers are in the hands of a very few, and no one representing the public interest can even grasp the issues, when the people have lost the ability to set their own agendas or knowledgeably question those in authority, when, clutching our crystals and nervously consulting our horoscopes, our critical faculties in decline, unable to distinguish between what feels good and what's true, we slide almost without noticing back into superstition and darkness. The dumbing down of America is most evident in the slow decay of substantive content and the enormously influential media. The 30-second sound bites now down to 10 seconds or less. Lowest common denominator programming, credulous presentations on pseudoscience and superstition, but especially a kind of celebration of ignorance." Roll that around for a while. Those were among his final published words. He died 10 months later. Here we are 25 years later, realizing just what he was trying to tell us.
We seem to have lost focus and vision, to have lowered our sights and let systems and structures and bureaucracies muddle us along. But we are capable of so much more. Our technologies permit us to manipulate time and space. They leave distance annihilated.
We're very powerful. This country is very powerful. It's far more powerful than people understand. We have weaponry that nobody has any idea what it is, and it is the most powerful weapons in the world that we have. More powerful than anybody, not even close.
Malaysian 370, contact Ho Chi Minh 120.9. Good night.
Good night, Malaysian 370.
Breaking news tonight, a Malaysia Airlines flight with 239 people on board, including 4 Americans, has gone missing.
From the Hindu scripture, the Bhagavad Gita. Vishnu is trying to persuade the prince that he should do his duty, and to impress him takes on his multi-armed form and says, "Now I am become death, the destroyer of worlds."
Welcome, everybody, to the live stream. Happy Monday, everybody. Wow. Guys, I was late for a minute because I just got blocked by Lex Friedman. Wow. Normally, I would crash out in a situation like this, but honestly, I just don't even care anymore. I don't even care anymore. I don't care about Lex Friedman. I don't care about podcast bros. I don't care about Joe Rogan. I don't care about politics and what side people are on or any of that crap. I'm just kind of over it. I'm over everybody being retarded all the time. I guess my take is just this, like, you do you, little bro. Here's my take. Here's my thing to Lex Friedman. You do you, little bro. If you want to just lose your mind because I said that you thought the videos are fake, I was just assuming, man. You ghosted me like 2 years ago. What am I supposed to think, bro? You ghosted me and unfollowed me and went away. And I didn't say anything about it for 2 years. And then you interview David Kirkley, which is who the podcast, I've been talking about the guy nonstop for 2 months straight about helium fusion. And now you're interviewing their CEO. And I'm staring at field reverse configuration plasmoids in the MH370 videos. You're expecting me to not comment? Of course, I'm going to fucking drag you, bro. I guess I am crashing out. I guess I am going to crash out on Lex Friedman. Bro, if you want to steal any more ideas from me, just come to me directly and I'll tell you who to interview. I'll tell you who to interview. Now, I'm still going to go ahead and give you props because I don't really care. I'm not the kind of spiteful person. I don't block people. I don't really care. But reality is, we are so far ahead of you. You don't even know where we're at. You literally don't even know how far ahead of you we are at. MH370X, this community, bro, you're not even in the dust. Like, we are lapping you and we don't know where you are anymore. We're talking about warp drives, anetronic fusion, free energy for the world, which is going to be described today, thermonuclear weapons, where the technology came from, potentially going all the way back to the Nazis. We're talking about how this connects to UFOs and disclosure. We're talking about what this means for humanity going forward for the next 1,000 years. And you guys, you podcast bros, are still busy trying to figure out what color the aliens are at. What color is this alien going to be? A blue one, or is it going to be a green one? You don't even see the bigger picture. You don't even see how significant of a revelation we are talking about here. And we are broaching directly on free energy. David Kirkley says it in the interview today. He gives the secret away, and I don't make people wait, so I'm going to tell you guys right now. He says we can get coefficient of performance greater than 1. We can get more output than input, but that's not the revelation. All fusion is aiming for Q factor over 1 or effective over unity greater than 1. They're aiming for a lot higher than that. And that's amazing, because in that alone could be argued that that is essentially unlimited energy, because we have unlimited hydrogen around us, practically unlimited. It's the most abundant resource in the entire universe. But it goes further. Not only can we achieve over unity output in our system, we can recycle nearly 100% of the input energy too. We're going to watch the clip tonight, including the several other clips, and pray that we don't get copyright striked. But Lex Friedman didn't even react to that. When somebody says, hey, man, we're going to get this over unity output, I'm going to put 1 unit of energy in, and I'm going to get 5 units of energy out. And we're going to try to collect as many of those 5 units as we can. And, oh, by the way, we're going to get that unit of energy in. We're going to get that back too. What would you call that? What would you guys call that? I would call that free energy. Not just that, because now you've added a scaling factor where the more that you are recouping, your efficiency is now increasing multiplicatively. Your overall system efficiency is now going way up. So fusion energy represents not just the most efficient form of electrical energy, direct energy conversion into electricity, but it seems like there's a big secret here when it comes to electrical engineering. So tonight, guys, now that I've done my little crash out, and really I don't care, guys. Like, if you have not learned anything from me in the last 2 months, IDGAF, guys. IDGAF. Right? I don't care about what people think. I don't care about the followers and what have you. I'm just a guy out here spitting facts. Take it or leave it. The truth is generally very unpopular. So I had done a bunch of research, guys, to do this live stream tonight, because the last couple nights I've been thinking about field reverse configurations, Sphere Max, the MH370 videos, the orbs in them. And I have learned, but I think we have learned that the configuration, the spherical shape of the plasma orbs in the MH370 videos, with the dark lines coming out of them, is extremely specific. And this is the reason why, they had to cover these up. Is that the shape of these plasma orbs, the heat signatures, the X-ray lines coming out of them, this is like having a fingerprint. The debunkers used to say it's like when you have your stock effect is matching, it's like a fingerprint and blah, 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 all this bullshit. Now, this is like a fingerprint. Like, there's only so many things that these plasma orbs can be if we assume that this is a real video and that that's real physical effect happening right there. And really, it's like only one thing. What we've concluded is only one thing. Those are fusion reactors. Those are plasma fusion reactors. That's plasma surrounding it. And it's a spherical shape. So I'd done all this research that we were going to review here. And then amazingly, today, this interview with David Kirkley drops. If you're not familiar, David Kirkley is the CEO of Helium Fusion. I have been making Helium Fusion as famous as possible. Now, I'm not going to take all the credit, but I've got to say that I have to be the number one cheerleader. I have 300,000 followers, and I shout them out nonstop. So I'm going to say I'm the biggest cheerleader at a minimum. And there's David Kirkley talking to Lex Friedman about fusion. So let me just quickly show you what I was planning to go through. I think it's this one. So I had this whole series of things ready to go here, starting with this Reddit post about the difference between Spherimac versus FRCs, some of the interesting history about Spherimax, and I'm going to talk about some of this stuff, but I don't want to waste that much time on it anymore because we have something better to watch now. But the history of Spherimax compared to like the sun, the theoretical backgrounds. Look at this heat signature that you're looking at right here. That looks really, really similar to the MH370 videos. I had this paper I found here about this Chinese paper on research of an unconfined Spherimac and its current path in a magnetized coaxial plasma gun. I was ready to go, chat. I had everything ready to go. Look at this paper that I found here as well. Lawrence Livermore National Laboratory. This was what, 1990 or something like this? 1999. Look at this paper. The Spherimac path. And they're literally talking about how to make compact fusion reactors. I mean, that's pretty much what they're talking about here. So I found all this stuff. I even had plasma beta. I even had the Wikipedia for plasma beta ready to go because I wanted to teach people, what is plasma beta? Why is it so important? And then Lex Friedman goes and one-ups me and interviews David Kirkley, and every single one of these questions is being asked and answered. So we're just going to watch that instead. And we're definitely going to get copyright striked in the middle of this. So I'm going to do my best to either do whatever tricks I can, and I'll deal with Lex Friedman after tomorrow or something like that. We'll see. But he's definitely going to come after me. I think he's litigious when it comes to copyright strikes. So, guys, we're going to try our best here. Get ready. Oh, before we do that, I'm just going to go ahead and explain why plasma beta is so important. Because this is probably also the most important aspect of all of this. Here's the secret. The secret is magneto-inertial confinement. So everybody knew that fusion was a matter of squeezing stuff together. We knew that since going back to the hydrogen bomb, even before the hydrogen bomb in the 50s. In the 50s, we know. So they were using magnetic fields to cause this to occur. That was the thought process. Crap, I just forgot. There's two things I want to say on this. So from the fusion perspective, we learn space-time manipulation because we're compressing energy down to a smaller and smaller, compact, more and more dense region. We're trying to squeeze this down. Crap. Okay, never mind. Oh, yeah. The others here, so there's two secrets to it. One is the one we already talked about, which is space-time manipulation. Space-time manipulation, if we can cause fusion to happen, if we can compress our energy matter down, we can increase our energy density. Number two thing that we figured out is that we have to flip our magnetic field configuration around. We have to flip our magnetic field configuration around. What we're trying to do when we're trying to do fusion is we're trying to build electromagnets that are containing our plasma, right? We're making our donut. We're making our stellarator, right? We're making our donut shape. So instead of doing that, the problem is that the plasma damages the wall reactor, damages the magnets, deteriorates the device. So what we do instead is we have no confinement. There's just nothing. The magnetic field is the confinement. That is the confinement. So we have our magnetic field be the thing that's confining it. And in order to accomplish this, we need a high beta factor. High beta. Now, what does that mean? Beta is the relationship between the plasma pressure and the magnetic pressure. So what this means is that if we can get the magnetic pressure and the plasma pressure close to 100%, the beta close to 100%, this means the relationship between the temperature and the pressure is equal to the square of the magnetic field strength. Okay. I'll show that on the screen here. If our beta is close to 1, the ratio of the plasma pressure to the magnetic field strength is close to 1. And what that means is they're equivalent. What that means is they're the same. That means the temperature and pressure is equivalent to the magnetic field strength squared divided by 2 something or other, 2. So what this means is the higher we get our magnetic field strength in this configuration with the high beta value, the more fusion we get. But not just the more fusion, we get exponentially. The number increases exponentially because it's beta squared, or it's B squared, magnetic field strength squared. In fact, I think he argues in this interview that it's even higher than that. It's like B to the 3.14 or something like that. So what this means then is, as long as our magnetic fields get more and more powerful for this spheromac that we're trying to produce, we are definitely going to get to fusion. There's an image that I'm going to show in here where David Kirkley shows the reactors. And the most recent reactor that helium fusion showed that achieved 100 million degrees Celsius was only 8 Tesla. 8 Tesla. That got to 100 million degrees Celsius. So what this means is that we can get to Teslas of like 20 or higher. We can double that. So if we could get to 100 million degrees just from 8 Tesla, from pulsed electromagnets, they can get up to 100 Tesla. They can get extremely high Tesla. So we can easily get fusion to happen using this method. And in fact, I'm almost sure this is the method that they use to get fusion to work. This is what they did. They created a high beta fusion reactor, which is just flipping the magnetic fields. Instead of having the container on the outside, the container is on the inside, producing the magnetic bubble around it. That's what they figured out. And when they did this, this made it so that there was now a relationship between the magnetic field that's trying to compress the plasma and the plasma trying to push out on the magnetic field as it's fusing. And then all they had to do was find a material that would produce an extremely high electromagnetic field, like a superconductor. And then they had to figure out how to shield that superconductor so that the plasma would not destroy it on the inside. So the plasma just doesn't ever really touch it on the inside. And once they had that, they molded it. Boom. Now you've got mobile fusion reactor that can float around. Okay. That's the secret. Let's get into this spice, guys. Here we go. We got a lot to go through. Where's the video? Okay. Let's start. I'm actually really concerned about getting copyright strike now. Okay. The first Yahtzee for tonight. I'm just going to tell the Yahtzees because I've already watched most of this and made up my minds on a lot of it. First one is that in a nuclear reaction, when we're making a nuke, fission, We are causing a chain reaction to occur where the neutrons, we rip an atom apart and neutrons go flying out, and those neutrons hit another atom, and then that atom splits, and it causes a chain reaction that cascades. That's not what we're doing in fusion. That's not what we're doing in fusion. So that right there is huge, because let's apply that to the MH370 videos. We're not looking at a chain reaction of an energy release in the MH370 videos. We're not looking at a huge boom, right? We already knew that, but now we understand the reason why. The reason why is because fission bombs will release neutrons and have neutrons spreading out. A fusion bomb does the exact opposite. A fusion bomb is going to implode. In fact, this is where the question should be, what does a fusion bomb even do? If a neutron bomb or an A bomb is releasing neutrons everywhere as it cascades and has a reaction like that, what is a fusion bomb even designed to do? What does it do? Is it supposed to just implode an object into a size of a pinhead? Because that's what logically, from a physics perspective, you would expect a fusion bomb to do. A fusion bomb is the opposite. It's an implosive effect. So you're compressing something down from all sides. So anyway, let's get right into this.
A type of hydrogen called deuterium, which is a heavier isotope of hydrogen. Hydrogen is typically 1 proton and 1 electron, atomic mass of 1. Deuterium is an atomic mass of 2, which is a proton, which is a charged particle, and it has a neutron in its nucleus, which is an uncharged particle. And so that's deuterium as the fuel. Now, deuterium is also found in all water on Earth, in the water I'm drinking right now. It's in my body. It's in Coca-Cola. It's everywhere. And safe and clean, and one of those fundamental particles that was born in the cosmos. And we estimate that in seawater here on Earth, we have, if we powered at our current use of electricity, all of humanity on fusion, somewhere between 100 million years and 1 billion years of fuel in hydrogen and deuterium here on Earth.
And so the thing about fusion is that it's not free. But again, free now becomes a matter of what's your perspective on the universe and whether or not you think there's an extra dimension where all energy comes from. But let's just assume a classical understanding of science, because I think it's simpler, is it's not a renewable resource, right? It's not like the sun or wind that just keeps coming back. When we're talking about this, we're talking about actually using up the hydrogen and converting it to another element. So in theory, it's non-renewable. But at the same time, if you go through and do the math, 100 million years, assuming our current understanding of physics and technology, we're probably fine with 100 million years. It's essentially unlimited. It's unlimited in a similar sense, not quite the same scale, but the same idea where people say, if we can tap into space-time zero-point energy and pull energy out of space-time, then does that use up the space-time? Technically, it might. But there's so much, it's so vast that it's inconsequential. It's essentially infinite. So similar kind of idea to that. I'm going to skip ahead here a little bit, because I want to get to the meat and the potatoes of this. There's actually a part in the middle that I think is the best. And I think I already explained what I wanted to do on the first stuff, or talk about on the first stuff. Oh, yeah. One other thing that he talks about here, about if it's safe or not. So here's the other thing. Fusion energy is safe in the sense that we're talking about releasing a small amount of neutrons compared to fission, compared to classical nuclear energy. So it's technically safer. And since there's no cascading effect, since we don't have that cascade that we cause for nuclear fission reactions, A-bomb reactions, we can just turn it off whenever we want. Let me repeat this. This is huge. Why is it safe compared to a nuclear reactor? In a nuclear reactor, we're afraid of a meltdown. We're afraid of a runaway. We're afraid of a runaway reaction where it's going to boom, blow up, what have you. But in fusion, all you have to do is hit the switch and turn it off. The moment you stop feeding the fusion reaction, it's going to die off. Kind of like keeping a little fire alive, right? Keeping a little fire alive at the campfire. You wake up the next morning, there's a few smoldering coals. You keep it, burn it, right? Now, I think that a fusion reaction, if we were able to make one that's on the scale of a black hole, then I think you do have a runaway concern. But nobody here, definitely not David Kirkley, are talking about creating black holes. They're talking about energy production on a much smaller scale than that. If we were able to make a black hole, I think that's where we would start to look at Q factors in the thousands, millions, maybe infinite, essentially. But at that point, I mean, we don't know. We don't know. Okay. Let's skip ahead here. Okay, here's how nuclear fusion works. I do want to watch a little bit of this. So David Kirkley knows a lot, guys. I have to point out that he goes through kind of the history of inertial confinement fusion and how laser fusion separated from magneto inertial fusion and the subtle differences. As we suspected, they're all pretty much the same thing. They're all the same underlying concept, but they have slight derivations in terms of how they approach it. And it's very interesting because he's going to say here, but just in case I don't play the clip, that when they did laser fusion, they discovered something new about plasma. They discovered something new about plasma, and what they discovered was field reverse configuration. Field reverse configuration. Okay. Let's listen to a bit.
Inertial fusion, what you're trying to do is bring together and push together by a variety of means, physical means, those particles. You push them together. The most common is called laser inertial fusion. Our colleagues at the National Ignition Facility did this really well and made world records in the last few years for being able to demonstrate you can do this and do it at scale, where you take very high power lasers and pulse them together to combine them to do fusion for a pulse, for a very short period of time, nanoseconds, billionths of a second. The other extreme, and you mentioned tokamaks and stellarators. Stellarators are actually my favorite, and so we'll talk about those. Graduate student in fusion, the stellarator is the first thing you learn about because there's a mathematical solution for a stellarator that solves perfectly, and you can write it out and you can solve it, and analytically it's very simple. Building one is very hard, and so it's taken humanity a number of decades to be able to build stellarators, and we can do it now with the Windelstein 7X that came online in the last few years, being the premier stellarator in the world.
I should say all the different ways to do fusion.
So I think I've also learned what's going on in terms of, like, people say, and rightfully, there's good questions to be asked, which are like, Ashton, how, if they've figured this out, how is it, how come we don't have it right now? Right. The number one question is, if they figured out fusion with the H-bomb, the 60s were a long time ago. Why are we just now getting fusion online in 2025? Why is helium energy the one to do this? Why didn't it happen in 2000, 1990s? Partially the material science. Partially because, what did I just say early on? We need magnetic fields that are extremely powerful. We didn't have them. We didn't have super high temperature, high magnetic field strength, super electromagnets, whatever we needed, right? The other part of it is that he is actually like part of getting this out to the public. They've been slowly researching it over time, getting better at it. And the government wasn't the one doing it. It had to come from the private sector. So there had to be this whole process of, okay, these people know about it, and now they're going to go try to commercialize it. And they had to get blessed, by the government as well. So a lot of this goes back to the government labs and the people that worked on the government labs. It goes back to the initial funding was from the Department of Energy. He even says in this that most of the initial research came from SBIRs. Those are the government defense contracts that they give to engineers. So I think we are watching it play out. And their research, helium fusion, he says in this interview for the first time I had never seen anywhere else, that their first reactor started in 2003. 2003. So helium fusion has been doing this for decades. And this also lines up the MH370 videos quite nicely, because it goes to show that these people were working on it, but it's clearly being developed and advanced. And in the same window that plane disappeared, where we're seeing 3 plasma orbs spinning around the plane, clearly with this open magnetic field structure with no confinement on them. Anyway, I'm going to let him keep
going. All just looks so badass in terms of it.
Let me see here.
the galaxy, galactic cosmic rays, and solar particles that would come to Earth. That magnetic field, when you run a compass, you see the magnetic field from the Earth. So we know it's happening. It's all over. But how we generate it with electric currents is a little bit different. And what we do is that we have a loop of wire. And the simplest way to think about it is literally a round loop.
So something I wanted to point out here, I'm going to skip ahead a couple of minutes. He talks about the Earth, right? It's like the inspiration is look at the magnetic field lines of the Earth. Look at the magnetic field lines of the sun. In fact, we can see the magnetic reconnection occur when we see these plasma arcs shoot out from the sun. We know that we can magnetically confine plasma. How do we know it? We're looking at a ball of plasma every single day out there, magnetically confined. There's no container around the sun. And it's in a spherical shape, which should tell us that the equilibrium for that system is a sphere. It's a sphere. Look, we see spheres everywhere. So just to help people out, a toroidal shape, a toroidal plasma is a ring, a donut. And a poloidal magnetic field, not toroidal, but poloidal with a P, is flip that horizontally and draw your magnetic field lines around it, just like you would with the Earth. Just like what you would with the Earth. A poloidal magnetic field produces a spherical shape. Okay. Let me go ahead like 1 minute here. And then we're going to watch most of this, I think. Yeah. There's like a 10-minute rant that we're going to watch here. So if you guys think I'm skipping ahead here, I'm mostly just skipping ahead because I want to minimize how much we're watching in a long run here.
With electricity going around it, and you have a magnetic field inside of it. And then you have a test particle, a charged particle, an electron or an ion, which is, if you imagine, to generate this, I have a coil with electrons moving around it. But if I put one in the middle of it, in this magnetic field, some really interesting things happen. That electron or that ion, that charged particle, is what's called magnetized. And what magnetized means is that it's trapped on that field line. In fact, even really more interesting is that it oscillates around that field line. And so the way I think about this is if you think about the Earth's magnetosphere again, and you think about the charged particles, the aurora, the northern lights, is a charged particle trapped in the Earth's magnetic field going around the Earth's magnetic field. And in the same way in fusion, we do the same thing here on Earth, but in a smaller direction, where we trap these particles on magnetic fields, and they can go around and stay trapped to that magnetic field line.
How much of the physics at this scale?
He's going to ask a good question here. Yeah, I mean, honestly, I don't know why I have to beef with Lex Friedman. I just don't really care, but he does ask good questions during this interview. I wanted to give him a lot of props, and I'm still going to give him a lot of props anyway. I hope he doesn't take what I said personally earlier. I think he's just kind of emotional. I don't know. People takes the internet way too seriously. Crap, what was I going to say? Okay, never mind.
It was understood here, like how these systems behave when you trap the magnetic field in this way. Like,
yeah, trapped in the magnetic field, guys. That's the answer. That's the answer. The issues with plasma, with fusion, one issue is temperature. We solve that. High magnetic field, higher magnetic field causes higher temperature, more fusion reactions to occur. Get the highest magnetic field strength that you can get. Number one issue. Number two issue, control, confinement of the plasma. How do you make your plasma confined when it wants to shoot out in every direction, guys? How do you do that? Spin it around, get it to move, get it to vibrate. All the things that we've been learning about for the last 2 years. Get it to act in sync. Get it to line up. He says the magnetic field lines, the electrons will get trapped. They'll get trapped. The reason why the bubbles in MH370, the videos, the orbs, we call them, I guess. The reason why do they look so stable? The orbs look so stable. It almost just looks like a little snow globe moving around. But it's flying through the sky. Shouldn't it getting blown in every different direction? No, because the magnetic field lines are locking in the charged particles. Locking it in there. In fact, it's almost identical to if we were to look at the tokamak reactor. There's a video of the tokamak reactor. You can see the plasma spinning around, and it's very faint. You can see a little bit of plasma. You see a little bit of glow. We're looking at a much denser version of that. The more dense the plasma is, the thicker it's going to look. And that's the secret as well. It's 3 factors: temperature, there's a constant, Boltzmann constant, and then there's also the amounts of particles. The more you get, the more dense they're going to be. So remember, dense plasma focus. That was one of the papers that was connected to this plasma fusion propulsion.
Is this fundamentally now an engineering problem, or is there a new physics to be discovered about how the system is behaving?
In fusion, the physics we're using is actually quite old. That the fundamental electromagnetic physics is 1800s physics. The fundamental atomic physics is early 1900s. And so the fundamental physics of how these work is very well understood. Putting them all together into a power plant, that's hard. And so you can do the math. You can do the math. Every introductory grad student does the math on a stellarator and say, this is all I need to do. I just need to make a magnetic coil in this very complicated shape. And then fusion will happen. However, doing that in practice is actually quite challenging.
So maybe you could speak a little bit more. So the stellarator and the tokamak, what's the difference between those two? They're both magnetic fusion systems. And then what does Helion do?
The tokamak and the stellarator are both magnetic systems. Their goal is to generate this magnetic field and hold on to the fusion fuel long enough. Like I mentioned, these charged particles are trapped on the magnetic field. In fact, they're oscillating. We call that a gyro orbit, as the radius that they oscillate around.
So that right there, you just saw the images. That was those fusion reactors. So what's the difference? Well, the fusion reactors that Helion is doing can produce much more dense plasma because their beta is a lot higher and their magnetic field strength is going to be higher. So they're going to be able to produce a much more dense plasma than those reactors are going to. Now we can kind of understand why have we not had fusion for so long? Because we've been going about it the wrong way. In fact, I'm off on basically every other form of fusion that's out there. If they're not doing a high beta concept, I have zero faith. And that actually includes Commonwealth fusion. I don't know what's going on with Commonwealth fusion. You guys can make your own judgments based on that. But they're working on like tokamak type styles. So I don't see how they can achieve the level of efficiency that David Kirkley is talking about in this video. Okay. Talked about oscillating there. So he's actually going to talk about the history of it here. I'm just going to skip ahead like 1 minute here.
Too creative with the terminology. We call the technique that Helion uses magneto-inertial fusion because it does a little bit of both. So to understand that, we can actually go back in history a little bit and think about the evolution of some of these approaches to fusion. And so from our perspective, we look at the technology that we use as built on physics experiments that were very successful in the 1950s. And in those systems, the earliest pioneers of fusion said, we understand the physics. We have to take these gases, heat them to 100 million degrees, and then confine them, push them together so that fusion happens. And so what is the best way to do that? So some of the earliest programs, we call them the theta pinch. And what those programs were a linear topology because we knew how to build these magnets. It's called a solenoid, where you take a series of electric coils, you run electrical current through them that generates a magnetic field. Great. So you have a magnetic field. Now you add your fusion particles. Okay. So you've added fusion particles to this solenoid. Here's the challenge. Those particles, as they're sitting in that magnetic field in this nice magnet, escape. They leave out the ends because there's nothing holding them in. Great. So that makes sense. And so that doesn't work. Okay. So then the next.
So great. What do we just learn there? First of all, he goes, people were working on this in the 50s. Wow. Yeah. I mean, the podcast hasn't dropped yet, but the Jason Giorgiani podcast is about to drop. And you're going to learn about, what's his face? Ronald Richter, 1953, 1952. This stuff goes straight back to the 50s. And then, like, his research got classified. They said it didn't work. They're like, nah, don't worry about Ronald Richter. Don't worry about his basically a neutronic fusion reactor that he's building. Forget about that. And then they started trying to do it. And then what we're going to find here is that the research, I did my own research on those slides or those websites I was showing you guys. And this science kind of just got defunded in the 80s, in the late 80s. So they were doing this science into magneto-inertial fusion. And it just kind of went by the wayside for some reason. And then David Kirkley shows up in the 2000s and what's his face? The guy that worked with Richard Eskridge, the other founder. But these guys show up and now they're picking it back up again. So I was already convinced that this stuff went back to the fusion bomb and our research in the fusion bomb. And now we're drawing even more parallels. And it's also connected to plasmoids and EVOs. You're about to hear David Kirkley talking about plasmoids and EVOs, the very same thing that Ken Shoulders was talking about. The very same, the Marauder program, guys. The Marauder program in the 90s that went classified. They were shooting plasma toroids at each other. That's what helium fusion is doing. That's literally what their reactor does. I couldn't believe this. I'm just sitting here going, wait a minute. So did it just go dark? Is that the secret? That this whole area of research, all of this magneto-inertial fusion, it went dark because it was all being classified under the nuclear weapons secrets. And it went dark, and it partially got defunded because nobody knew what it was or what it did. People are like, you can't talk about it publicly. You can't be like, hey, man, we made some weapons and they're just manipulating space-time. By the way, they're based on the H-bomb. People just look at you and they would just laugh. They would be like, oh, yeah, okay, yeah, you're doing Star Trek? Uh-huh. Are you going to put on your Star Trek clothes and go to the convention? That's what they would say to you, 100%. So it gets defunded. And then I don't know exactly how it picked up, but now I'm starting to see, like, this is what the deep state is. No offense to David Kirkley. I don't care if you're deep state, guys. They think I'm deep state now. But this is what the deep state is, though. The deep state is a group of people that know about weapons secrets that even the public doesn't even really believe are real. And they're profiting off that knowledge. Computer technology secrets, microelectronic engineering secrets, you would call it gravity manipulation secrets, fusion, plasma, topological research, all of it. They're all profiting off of it. And they know the other people that know, and then you have a club now. No individual is actually evil. They're just driven by their own incentive structures. Okay, I've ranted too much. Here we go.
Approach to say, well, one branch of fusion said, okay, well, to solve that, why don't we take this solenoid and bend it around? Let's just make it a big donut. So as they're escaping, they go around and around in a circle. Great. That's a great approach. And so one branch of fusion went down that direction. And that evolved into the stellarator and the tokamak. Different ways of taking those solenoids and wrapping them around so that the plasmas go round and round in that magnetic field and those charged particles are held long enough that fusion happens. But there's a different way to do it. And so the theta pinch was what was born in the 1950s of take this magnetic field and, they're trying to escape. Great. Let's not let them escape. Let's close the bottle. Let's close the ends. And so we make the magnetic field much stronger at the ends. This one was called the mirror.
I already knew what he was going to say here. If you guys watch my content, when he says this here, he goes, okay, the problem is the plasma is escaping. We try to do a theta pinch. The plasma is escaping out. Well, we already know the answer to that is let the plasma escape, bro. Use it as propulsion. Use that as your propulsion. Use the exhaust. But we knew the answer. The answer is a mirror configuration. Remember the mirror? And remember what else is good about the mirror? The mirror is also used to produce a free electron relativistic laser. We produce mirrors, have them vibrate, and you can speed up. You can create a particle accelerator. You can make a laser or an X-ray laser, essentially, with it. So I think the byproduct of them producing these fusion reactors that are mobile fusion reactors is that they produce X-rays. They give off X-ray exhaust. Anyway, let them keep going here.
And so the idea was that the particles would bounce in between. And that worked. And they got hotter and hotter and hotter. But guess what? As you kind of would imagine, as this mirror topology, this linear topology, the pressure increased inside. The particle pressure, the particles tried to push back on the magnetic field. They're trying to escape now. They're getting hotter and hotter. And just as you imagine, hot gas in a balloon tries to get out the ends. And you could not hold it tight enough at the ends to keep those particles in. And in fact, the problem is the hottest ones were the ones that would escape. And so you do a good job of heating it and they'd all leave out the ends. Okay. So then the next iteration is said, okay, well, why don't we just not try to hold on to it very long? Why don't we squeeze it? And so rather than just holding it constantly, let's now crush it. So we built this solenoid, we pinched the ends, and then we crushed it. And what I mean by crushing it is not actually like crushing any magnets or changing the topology or moving any parts, but just rapidly increasing the magnetic field. And so going from a magnetic field that's just holding it to now taking all those particles, if you imagine they were in a streaming around together, and then rapidly increasing the magnetic field so that those particles get closer and closer together. So you increase the density. And now fusion starts to really happen. But they ended up hitting a technological limit. So this is the part that I look back and I look at the pioneers that in 1958, there was some...
I mean, this is wild, man. This is it, man. This is it, chat. I am getting goosebumps listening to this because we have figured it out, man. This is the big secret. The big secret is fusion and what fusion is actually capable of. And he says, we know what we have to do. We knew the answer. We know the answer. What's holding us back right now? We have the math and the equations right in front of us. And it says right there that the pressure is going to be equal to the B squared divided by 2 times the electric permittivity or permeability of, or the magnetic permeability of free space. There it is right there. There's the answer. We don't have the material science. That was the thing that was holding us back in the 50s. It was a long time ago. We didn't have the material science we do now. So when did it get figured out? If somebody were to ask me or to ask you, Ashton, MH370 Orbi out there, when did it get figured out? You don't give them a date. You don't give them a date. You say, we figured it out the moment we were able to develop magnetic electromagnets that were powerful enough. When did that happen? Maybe in the 90s. My guess, if I have to guess, computers, we needed computers that were powerful enough. Yes, person in the chat, we needed computers, and we needed super powerful electromagnets. And we got those electromagnets in the form of YBCO superconductors. Who's famous for those? Oh, Ning Li and Eugene Potkanov are famous for their YBCO superconductors. YCBO. I always say it backwards. What is it? YBCO super. No, I said it right. YBCO superconductors. The high temperature superconductors, yttrium, barium, copper oxide. Now, I'm sure we have other options as well. I mean, that was 30 years ago. But the moment that our material science took off, we had this figured out. And who would be the first person then? If now we know the parameters, the physics was figured out in the 50s, the material science needed to catch up. We know it got figured out when the material science got figured out. Who would have been the first person to figure out? Which groups would have figured out the material science first? It's going to be the United States government. It's going to be Lockheed Martin and the companies that came before Lockheed Martin, the Boeing. It's going to be Boeing. It's going to be Raytheon. It's going to be General Atomics. It's going to be all of these companies. The defense contractors are the ones that figured it out first. That's why Lockheed Martin with their compact fusion reactor, that should be setting off red flags and warning bells, alarm bells for everybody. The moment Lockheed Martin came out and basically copied what helium fusion was doing, literally just copied what they were doing. They didn't even say it because they probably didn't want to get sued. It's pretty obvious when Charles Chase says, we're making something with a high beta value. We know exactly what they're doing. You're making something with a high beta value. You're using a field reverse configuration. We know what you were doing. You were doing the same thing that helium fusion's talking about, and they're talking about having it not be externally confined. They're talking about the plasma itself is doing the confinement. The plasma itself is producing the confinement. Anyway, here we go.
Pioneering work done, and this was in California, what later became Livermore Labs. There was also some work done at other national labs too. These were all federally funded programs to explore this theta pinch topology. Can you just squeeze the plasma down fast enough, hard enough? This was 1958. The transistor was sitting in the laboratory, and they were commuting. They were turning on millions of amps of electrical current, and they were doing it. We haven't talked about the timescales, but they were doing.
Wait a minute. I didn't pick this up before. The transistor. The transistor was a key linchpin in this taking off. Of course it was. The transistor is basically a switch. Oh my God, it's so obvious now. It's so obvious. Remember when we were thinking that maybe the UFOs brought us the transistor, guys? The UFOs, we got the research technology. Now, maybe we did. Maybe we got this from the aliens in the 20s or 30s or whatever, right? We got a UFO, but maybe we didn't at all. Maybe all of it goes back to nuclear weapons research. This is what's bugging me out the most, by the way, guys. I used to be a guy that loved the idea of aliens and aliens visiting us, the thick whites. And now I don't even believe in aliens at all. Now I'm like, I don't even know if there are aliens out there. And if there are aliens out there, they might just be like machines. There might be machines out there. And we might be so primitive. We might be so primitive that we're not even on their radar. Not even on their radar. Man, Chad, these videos ruined me. Okay, sorry, let's keep going.
And in millionths of a second. microseconds, megahertz speeds. And this was in 1958. No transistor, no CPUs, and no electrical switches, none of the things that I take for granted every day. And so they were able to show at that time the highest performing fusion systems. They got to temperatures, they didn't get to 100 million degrees, not quite then. They got to 50 million degrees. They were outperforming everything else in fusion, but they reached a technical limit where they just could not build it anymore. And so those pioneers went in a different direction, and they started down the laser inertial path of saying like, okay, well, we can't do these electromagnetic pinches, but we now have this new thing has invented the laser, which turns on in a nanoseconds. It's fast, it's interesting. Let's go down that path. And it's not, you have to fast forward a couple of decades to researchers found with some of these theta pinches, when they're operated in a very specific way, something else happened, something new happened. And that these plasmas, where before they squeezed them very hard, and just like squeezing a tube of toothpaste, they squirted out the ends. Now it didn't squirt out the ends. It actually pushed back. It stayed confined. It stayed trapped inside that linear topology. Even though the ends were open, the plasma didn't leave. And so there was a large amount of programs of like, what is happening here? This is an accidental discovery in plasma physics that something new is happening. And what we discovered is we now call the field reverse configuration.
Pause chat, Galaxy class pause chat. What? They were messing around with theta pinches, trying to get the plasma to act right. And all of a sudden, it just started stabilizing. It just started self-organizing, is basically what he just said. They discovered a new property about plasma where it started. He said the doors were still open and the plasma just chose not to go out them. The plasma just didn't want to go out. And they decided to call this brand new discovery of plasma. What did they call it, chat? Field reversed configuration. Boom, baby, boom. Suck my dick, Lex Friedman. Boom. Chat, OMG, chat. We were right. Ashton Forbes was right. Get the apology form. Start printing out the apology forms. We're going to need stacks of apology forms, chat. MH370, cold fusion, literally blowing the lid off of cool fusion like 5 years before it even happens. Chat, just get the apology forms ready. I got all the people's Twitter posts saying how much of a dickhead, a hoaxer, a scammer I am. Oh, my God, chat. Someday in the future, we're going to have the greatest day ever. It's going to be the greatest day ever, chat, when everybody has to acknowledge that MH370X was right the whole time. We're going to just have a live stream for 12 hours straight. We're just going to go through all the people's posts, all the douchebags, all the idiots talking crap. It's going to be amazing. Okay. Wow.
There's numerous programs of FRC, field reverse configuration programs, both at national labs. There's actually a number of private companies now of people building field reverse configurations, and they have some really unique properties. But fundamentally, talking about the main difference, I described a solenoid with magnetic fields throughout the center of that volume and plasma trapped.
By the way, that graphic right here, if you're listening on audio, it's a graphic of two rings with like stuff spinning around in the middle. This looks just like the images of Lockheed Martin's compact fusion reactor. Like literally it's just a series of concentric rings of different sizes. That's it. There, I mean, you're basically looking at the graphic.
Going back and forth, but some other things can happen, which is really interesting. And what they discovered early is if they have field going in one direction, so the plasma, the electrical current is going around the loop, and the plasma is going back and forth along this magnetic field line inside that solenoid, inside that theta pinch. But then they changed the direction of the magnetic field, and this is what we call field reversal. And this is really the key: is that you start with the plasma going in one direction, and then very rapidly you change the direction. You change the direction and reverse the direction of that field, and something really interesting happens, which is the plasma, this fusion fuel, these charged particles, which are trapped on the magnetic field lines. That are moving back and forth, you change the direction. What that means is that you're trying to take that electrical current and that magnetic field and reverts its direction, flip it, but can't flip fast enough. The plasma is sitting there and you can't move the particles. And so what's really interesting is what happens is that because the particles can't move, but you've now flipped the direction of the magnetic field, you've inverted it, something really, really unique happens, which is that the plasma itself reconnects internally. And so now what you're left with is an outside magnetic field, an electrical coil, and inside the plasma, where now before it was moving along, it's now moving internally.
Rapidly reversing the magnetic field.
Wow, chat. Do you guys? When I heard that, man, I was just like, wow. Direct connection to free energy right there. How do you guys think free energy works in a magnetic motor? How do you guys think that it works? Right? When we talked about parametric amplification of oscillations of electrical energy, what we're talking about in terms of like how we're going to produce free energy is we're going to use the back EMF, the collapse of the magnetic field. So you build your magnetic field up, and then your magnetic field collapses, and electricity flows when there's a changing magnetic field. So the idea is that why does a pulse matter? Well, when you're pulsing on and off your magnetic field. You're pulsing it on or off. So this idea of pulsing the magnetic field strength, if that same concept, that's the same exact concept that we were using like for Bendini motors, the same concept that we were using for serial magnetic motors is the same thing that we're using for our plasma reactor. We're using the same physics for free energy devices that we are using in our plasma reactor, fusion reactor. That tells me even more that what we're talking about when it comes to free energy really is some fundamental aspect of the universe that people have found how to tap into in multiple different ways, whether that be from an electromagnetic motor or a magnetic motor that can tap into 0-point energy from using these types of oscillations and amplification, or directly going to the source, which in my opinion is plasma fusion. And yes, how do you allow free energy? So the thing that I'm doing here is I am turning this topic, call it what you will, 0-point energy, a neutronic fusion, turning this into a political discussion, turning it into a political topic. People don't want to talk about it, but I'm going to turn it into one because it needs to be discussed. All the implications of what this means need to be discussed. I talk about them with Jason Giorgiani. I think that's the biggest thing that we need to talk about is how do you implement free energy and what safeguards do you put into place? Or we only get the nerfed version of it? When do we get to teleport throughout the universe? Right? These are the big questions that I think should be asked. When is it going to be safe? How much do we really know compared to what they're telling us? Okay, here we go.
Field plasma self-organizes into a closed field.
Mhm.
What?
Yep.
So
It sounds wild.
it's yeah. So first of all, there's a million questions I have. So one of them, what's rapidly? What time scale are we talking about here?
You have to reverse the electrical current faster than a million degree, which is a very hot gas particle, can move. And so that means we have to do it on the order of a millionth of a second.
Wow.
We have to do it in a millionth of a second.
Wow.
And
so you just think about it. What did I just say? You're abusing the collapse of the electromagnetic field strength here. So how do you get that to work? You have to make the collapse happen. The time scale has to be faster than the electrons themselves. What does that mean? That means they have to be relativistic. We're dealing with relativistic implications here. It's exactly what he's implying right here. He's saying you need that pulse to be so fast that the magnetic field can't even collapse faster than that. So that when the electron turns around, now it's bumping back against the electromagnetic field that it created. So now this is very similar to the core concept of vibrating the walls on our our plasma mirror to make a relativistic electron laser. The same thing that was being discussed by Paul Thibodeau when he talked about the drift velocity of graphene. Why are all these things connected? Because it all goes back to the electron, how fast the electron is moving, and then having relativistic motion. So if I go left and you go right, then our combined relativistic motion is the speed combined. Add the speeds up. That also applies even on small scales, even on tiny scales that applies. And this is why my view of the universe is that there is this, that there's nothing that's ever really stopped. Nothing's ever really stopped. I'm going to go on one quick tangent here. The answer to the Hal Puthoff question I now know what the counter response is when Hal Puthoff says the ground state of the hydrogen atom should be radiating energy all the time, because there's an electron, and this electron is moving around the nucleus. So in a conventional view of our atom, the electron should be radiating energy. It's moving. Anything that's moving should radiate energy. Otherwise, it's a perpetual motion machine. The second law of thermodynamics says anything that's moving should lose a little bit of energy. So the electron should eventually crash into the nucleus, but it doesn't. And so Hal Puthoff says that electron must be gaining energy from the 0-point energy field. There must be another source of energy for that electron to stay stable. The classical view, the counter view, is that they believe that at the quantum level, nothing is moving. It's all stopped. It's all frozen. To me, that's the easiest thing to disprove. Easy to disprove. The fundamental rule of quantum mechanics is that nothing is stopped. It's the exact opposite of that. The truth of quantum mechanics is the exact opposite. That if we look at the smallest scales, everything is jiggling. That's why we call it the Zitribuagong. So this is the difference. This is where I now know where quantum mechanics went wrong. Now it all makes sense. Quantum mechanics went wrong when it started trying to talk about breaking down the wave function, collapsing the wave function. Started going wrong when it thought about, well, we're going to freeze this moment in time, as opposed to addressing the physical realities of the experiments that we were getting the responses for, as opposed to reconciling what we already knew about quantum mechanics. The pendulum is never stopped. The pendulum is never stopped in quantum mechanics. So hopefully that helped you guys get a little bit more context. Let's listen to a little bit more Lex Friedman.
And so in practice, this is hard. And we can only do it now because of semiconductor switching. Because we can move things, we can switch things like the transistor in every CPU in a computer switches at a gigahertz. That means in a nanosecond, it's switching in a billionth of a second. And so now, which we didn't in the 1950s when these theta pinches were invented, but now we have the semiconductors to be able to do that.
The self-organizing plasma. Can you just speak to that? What the heck is it doing? How do we understand the self-organizing mechanism, the dynamics of the plasma that it's able to contain itself?
So what I like to do is use an analogy here of once you've made it, it's actually somewhat straightforward to understand. Getting to it is tricky. And how they discovered it the first time is absolutely amazing. But once you've made it, it's a lot more straightforward to understand. So in a magnetic coil, when you have a round electrical coil, you have electrical current flowing in that coil. And if you have a conductor, if you have a metal inside that coil, and this is called Lenz's law in one of the Maxwell equations, is that as you have electrons and you have current flowing in that coil, an equal and opposite electrical current is induced in a piece of metal nearby. This is the same thing that happens in a transformer, where you have a primary on a transformer and you have electricity flowing it, and you have a secondary where electricity flows exactly the opposite direction. We use this every day in our lives. And so in this condition, you have a conductor, an electrical conductor where current can flow, and you have an electrical current flowing on the outside, electrical current flows on the inside. And in that case, now I've described two pieces of metal. Now, let's go one step further, and that inner conductor is not a piece of metal anymore. It's one of these high-temperature gases, this plasma, this charged particles. So now you have electrical current flowing in the plasma. And this is really, really interesting. We talked about these charges moving back and forth. Well, moving electrical charges is current. So in every plasma condition we've talked about, the tokamak, the theta pinch, the stellarator, there's electrical current flowing in the plasma. But in the field reverse configuration, you have a lot of electrical current flowing in the plasma, massive amount.
So now what he's saying here is that our plasma that we're producing, it's got a huge amount of current flowing through it. Because what is electricity? Electricity is technically just electrons moving. And that's definitely happening in our plasma when our plasma is moving around. So it's going to produce its own magnetic field because of the current that it's producing. So what we're talking about here is that we're figuring out how to use plasma to produce energy in the most efficient possible way. That's really all it boils down to.
And that's the key. So you have the center core where electrical current is flowing in this transformer, if you want to think about it, primary and secondary. And here's the craziest part of it. This electrical current, how did I describe a magnet? An electromagnet is a loop that has electrical current flowing in it that generates a magnetic field. And for a theta pinch, and for a mirror, and for a tokamak, in that magnetic field, the plasma gets trapped. But in an FRC, this electrical current is the plasma. And that plasma then generates its own magnetic field. And it's then trapped on its own magnetic field.
That's fascinating.
And that's the key. And so in your tokamak, in your donut, in your funky donut, your stellarator, you make the magnets and you trap your plasma in it. In an FRC, you make the plasma, which makes the magnets, and it traps itself. And the craziest part of this, in my mind, is that we actually see this in nature all the time. If you look at the sun, we see solar flares. And in a solar flare,
hold up, chat. Pause. Okay. Wow. Yeah, now they're starting to get caught up. Like this is Lex Friedman starting to broach on the letter to Ashton Forbes, which is like almost 2 years old at this point, by the way, chat. Letter to Ashton Forbes is almost 2 years old at this point. This is Lex Friedman starting to broach on the topic of plasmoids, self-organization, self-sustaining plasmoids, like smoke rings. They don't dissipate. They don't dissipate. They stay structured, and they can move around. They have a lot more stability than what has been expected. And this is where FRCs come into the game. FRCs are essentially using plasmoids. That is their function. That is how they are operating, is they're creating these plasmas that create this self-organization from this field reverse configuration that they produce. And it's self-organized, spontaneous self-organization. And so this property is almost certainly something that the government figured out and weaponized a long time back. And this is what Ken Shoulders was talking about when they were producing these plasmoids to teleport things, literally to teleport things. He said so directly.
We've all seen the pictures of the photosphere of the sun and this large arc of plasma coming out. That plasma has current, electrical current flowing in it. And then we see this solar flare rip off of the sun. And that solar flare then can flow throughout and continue into the solar system. And for a little while anyway, it makes something called a plasmoid. That plasmoid is in fact electrical current flowing in the plasma, generating a magnetic field and holding it for longer than it would otherwise. And so we've observed these for 100 years. And we've known about these plasmoids for a long time. And there's researchers that have tried to...
We see them everywhere in nature, he said as well. We see them everywhere in nature. Where's my thing? Where is it? Boom! Gotcha, bitch. The plasmoids. We see them everywhere in nature. They self-organize into specific shape. We need to be working with nature. That was the big secret all along. Instead of trying to work against nature, we should have just been working with nature the whole time. And so how do we build out the instabilities? Is we use the magnetic fields. The magnetic fields trap the particles. The magnetic fields are what helps the stabilities. And here's the other big secret: spin. Why are the orbs spinning around in the MH370 videos? Not just spinning around the plane. The orbs themselves are spinning. The helical motion provides stability for the plasma. The same exact way where if you were to spin a top on your desk, you spin it fast enough and it's going to stay upright. If you don't spin it fast enough, it's going to fall over. He uses that analogy. I stole that from him here.
Intentionally to make them. But fundamentally, that's what we do every day, is make one of these self-organized closed field plasmas.
In a more controlled way at this rapid rate of 1/1,000,000 of a second, and being able to make sure it's reliable and stable and all that kind of stuff. So by the way, how do you keep the thing stable?
And there's the hard part, because I just described a solar flare, but yes, we've seen the pictures of them, but we've also watched them, and they appear, they fly away from the sun and then they go away. And that's not what we want in fusion, right? We want to be able to control this. And so that's the hard part of the job. And so that's what we've spent the last number of years learning how to do ourselves and others on these pulsed closed field FRC systems. Let's first talk about how to make them, and then we'll talk about how to make them stable, because they're two different things, and we spend a lot of time on both. So we talked about timescales. You have to reverse the field. You have to change the electrical current in a millionth of a second. And so how do you do that? So I described this system as you have a series of magnets. You have a magnetic field on the outside, and then on the inside of this, you have this donut, this FRC, that has its own electrical current. And we didn't talk about this yet, but it's generating a magnetic field, and that magnetic field has pressure. And this is the other thing that's really interesting. So we talked about how this theta pinch compresses a magnetic field. It applies a pressure on the outside. But the plasma itself has a pressure on the inside. And it has both the particle pressure, literally the particles bouncing. Think about hot gas in a balloon. The particles expanding, the ideal gas law expanding and contracting inside a balloon. But they also have a magnetic pressure. They have the electromagnetism is pushing back. And so I like to think about this as the motor in a Tesla. In your electric car, you have a motor, electric motor. And what that motor has is a series of windings. Those windings, you flow electrical current, in this case from a battery, hit the gas. Electricity flows from the battery into the motor, into those windings, and it generates an electromagnetic force. A Lorentz force is what it's.
So this is funny because early on, when I talked about magnetic motors, people are like, magnetic motors already exist. They use them in Teslas. And here is David Kirkley comparing their plasma engine, their plasma fusion engine, which is really what it is at this point, directly to the motor in a Tesla car. Because it uses similar principles. Is that not only are we having fusion occur, but we're actually using the relationship between the magnetic field compressing the plasma and the plasma trying to push out on the magnetic field. We can use that. That's basically a piston. Imagine a balloon that you squeeze down and then the balloon goes back out when you let go of it, right? It's the same idea. That's work, man. You're getting energy out of that. You're creating an engine with that. They turned this into a rocket engine, but it's not a rocket. They converted it to like a heat engine. That's the best explanation. The best thing I can call it is plasma fusion propulsion, because that's really what it is. But it's somewhat equivalent or similar, analogous to just a normal engine. Yeah, compression engine, I guess would be the right way to put it. So here we go.
Technically called. This electromagnetic force induces an electrical current on the armature, on the shaft. And this is getting into the details, but it's the armature of an electrical motor that actually is what spins. And so the outside of a motor doesn't spin. You flow electrical current through it, and the inside does spin. That electromagnetic force is what is spinning that armature. In our case, we're inducing an electrical force in that electromagnet, and that's putting electrical current, just like in the armature, into that plasma. And we can use that force to do interesting things. So that electromagnetic force can compress the fusion plasma, it can expand the fusion plasma, but here's the problem. It's unstable. And so this is something you learn very early in your graduate work as a student in fusion, is you learn about plasmas that are called high beta plasmas.
So he already just explained, we're about to learn about high beta plasmas, but he just said why the orbs are spinning. Why are the orbs spinning? Because we've got a plasmoid in the middle of that thing. There's a plasmoid in the middle of it, and it's spinning around. So that's why you see the whole orb spinning around. Now, here's the question that comes up. Is there something inside of the orbs? Is there something inside of the orbs in the MH370 videos? Based on what has been said so far, you could make a strong argument that you don't need anything inside, that you could shoot like a plasma gun, and that it would shoot out a plasmoid, just like a smoke ring, and it would just keep going. The reason why I think there is something inside, I do think there is something inside of the orbs. Twofold, two major reasons. One, the X-rays that we see coming out of the back and the front. That means there's something inside there that's allowing that to pass through as the axial symmetry. Basically, when I say axial, I just mean like the Earth, right? Number two reason, the orbs are being moved with intelligent motion. The orbs are actually moving pretty clearly with, it's not intelligent, but it's computer controlled, right? Computer controlled motion is what we see here. Watch very closely, specifically the first orb. If this was just somebody shooting with a gun, that orb won't be able to lock into the plane. Watch it lock into the plane right here. See how it flies past the plane and turns around? That's not just magnetic attraction. That is something directing it. They're being directed into those positions. The only way I could think that what we're looking at right here was purely naturally controlled would be if they all came together in unison. Instead of coming one at a time like that, which implies they're not being shot at it, there must be some kind of computer control inside of those things. Now, when they lock into position, they can pretty much just spin at will. But before they lock in, that to me, that requires some level of computer control. So, and also that same computer control will be used to fly them around through the sky. So I think there is something inside of those orbs. I do want to point that out. That's my current opinion still.
Seeing this plasma beta thing everywhere. What is this ratio of plasma field energy to confining magnetic field energy? Please explain.
Plasma beta is the ratio of the magnetic pressure to the particle pressure. And so what that fundamentally means is I talked about how you have a magnetic field. And in that magnetic field, plasma is trapped on that magnetic field. But it's not very well trapped. It can escape. It can leave either down the ends. It can freely travel, or it can also travel across the magnetic field. And so we have a term called plasma beta, which gives us an understanding of how well trapped that plasma is. So as you apply magnetic pressure, a magnetic field to this plasma, it pushes back. And does it push back a little, or does it push back a lot? And for a field reverse configuration in one of our plasmas, beta is very close to 1. In fact, usually by definition, 1 at any point in the system, which means that every time I apply a magnetic force on this donut to compress it, the plasma particles on the inside push back. And what's really interesting is you have an equation for magnetic pressure, which is B squared over 2 mu naught. The magnetic field squared is the external magnetic pressure. Any magnetic field anywhere generates this pressure. But the plasma particles themselves also have a pressure. This is the ideal gas law. And we use the definition in kT, density, Boltzmann constant, and temperature for pressure. And in high beta, they're the same. B squared over 2 mu naught is NKT. So for a known magnetic field, I know what the density and the temperature of the plasma is. And just
Jesus, chat, there it is. My goodness, that is the secret. I don't know how more people don't see it. I am sitting here watching this, listening to this, and I'm going, how do physicists still have to ask me why this is the answer? Why is this the answer, Ashton? Did you hear what he just said about high beta value? When the beta value approaches 1, the plasma pressure now is equal to the magnetic pressure. Okay, do the math. Look at them side by side. That means the temperature, what we're trying to achieve in fusion over here, is equal to B squared. Do you see those terms? That means as the magnetic field goes up, we're going to get exponential increase in temperature. Exponential. Exponential means increases a lot really, really rapidly. What this means is the moment we start to get very powerful magnets, we're going to get fusion. That's what the math says. Just the math, just the theory says the moment you get very powerful magnets, you got fusion locked up. Remember, 8 Tesla already produced 100 million degrees. 8 Tesla produced 100 million degrees. Do you guys think we can get above 8 Tesla? We've already proven we can get to like 20 to 100 Tesla. So yeah, I think we're probably safe. This is the reason why helium fusion's got a $5 billion valuation. The math shows it's going to happen. The math shows it's going to happen, no doubt. It's just a matter of when we get those magnetic field strengths.
to circle back to it. We talked about fusion. We talked about it had to be hot enough and it had to be dense enough. And that's N and that's T. So now I have a very clear equation between magnetic field and density and temperature of the fusion fuel. And that's really critical. All fusion plasmas have some beta, some number. The FRC has one of the highest betas, beta equal 1. However, what you also learn in school when you learn about beta the first time is you learn that high beta plasmas are typically unstable. And so the good way to think about this is a tokamak and a stellarator are stable because those plasmas that are going around in the donut, there's a force on that donut. But that plasma donut is very well held by all those magnetic fields, by all those magnetic coils. If it tried to move, it would be confined by that magnetic coil. But an FRC is unconfined. So the plasma is confined, but the whole topology can do something what is called tilt. Is that this whole plasma donut, because it's under pressure, can just turn over. The way I think about this is think about a motor is a good example. In an armature, in the center of your motor, you have a spinning armature. You have this spinning magnet on the inside, and it is held by the main axis of the magnet. It can't go anywhere. We don't have that access. We don't have any mechanical things inside these fusion systems. They're 100 million degrees. You can't put any mechanical things inside them. And so we have nothing to hold on to it. And so it's unstable. So when you learn about the FRC, that's the first thing you learn. And it took us a number of years to learn about a parameter of how to make them stable. And
so it's all about stability, right? This is where he talks about, it's like, what are the problems? Temperature. Well, we got temperature covered. Temperature is covered. We just looked at the math. B squared equals temperature times Boltzmann constant times N. There it is. Dense plasma. Your plasma is going to get really dense, really hot, really quickly as your magnetic field strength increases in your field reverse configuration. Next problem, stability. Stability was the same thing that George Miley was trying to figure out when he was trying to produce a free electron laser. He was trying to figure out, how do I get these beams, these laser beams, to combine together? And I think what he figured out was helical motion. Spin. Make them move. And again, why are the orbs moving? The orbs are moving because they're using it as stability. They figured out plasma stability too. For the MH370 orbs to be real, they have to they basically perfected stability. And I would argue, I think that a lot of the fusion papers argue that the more powerful your magnetic fields get, the more stable it gets as well. It's pretty obvious, right? The more powerful your magnetic field is, you're going to have a more stable plasma. The other thing they figured out, not just spin. Spin will help with stability. What's the other thing they figured out? Let some of it go. Don't try to hold it all in. Pulses, air-breathing magnetohydrodynamics. Create a magnetic nozzle, just like a fire hose. Just let the most charged particles, the X-rays, let those shoot out. Like we're ghost busting out here. That was the other thing they figured out, is let the exhaust pump out, and you can use that. You can use that exhaust as propulsion.
And that's pretty fundamental, but most people who've heard of an FRC haven't understood this really key fact. And so we have a parameter we call S star over E. And we're getting really into the physics weeds here, but
Let's go.
But it's really important. And the good analogy here is a top. It's literally a top, spinning top. And so you have a top spinning on your desk. You know that it'll spin for a little while and then it will fall over. It is unstable. However, if you spin it fast enough, if you take a top and you spin it fast enough, put enough angular momentum, enough angular inertia into that system, it'll stay upright, even though it wants to just fall over, even though it's unstable. And we do the same thing in an FRC. Is if you can drive it fast enough, if you can add enough kinetic energy and inertia to the particles, it will stay stable. However, you can do another really key thing. We are not limited now to having a very skinny top. We can actually make it much bigger. So the good analogy here is if you have a coin and you know you're spinning that coin, if you spin it faster and faster, it'll stay spinning longer. However, eventually it'll slow down and fall over. But if you had a roll of duct tape, if you had something thicker and heavier and longer, and it's spinning around that same axis, it'll stay spinning even longer, both because of the inertia and because of the geometry. And so we have this parameter called S star over E. S star is the hybrid kinetic parameter, which tells you how stable it is from that top point of view, and the E, which is the elongation of how long it is. And so
okay, so this is pretty interesting here. So let's look at this, because I'm not sure I fully understand this, but I mean, he's talking about the spinning top. So he's basically saying this equation should explain why, if we add angular momentum, if we add spin to our plasma, why it's going to be more confined, why it's going to stay more stable here. So the top value, S star, is the hybrid kinetic parameter. It's the measure of the plasma's kinetic energy and angular momentum. So the more spin we have, the bigger this number is going to be. So presumably we want this number to be pretty big. So we want a high angular momentum. The higher angular momentum will offset the bottom value, and the bottom value is the elongation of the plasma. How long the plasma. So the longer the plasma is, the more spin is going to be required to keep it stable. That's how I'm understanding this. If that's true, then what does that mean? If I want my E to be as small as possible, how do I have the minimum? What would be the minimum elongation? Let's think about that. What would be the minimum equilibrium elongation? I'm going to go ahead and guess that it's going to be a sphere. How do you minimize elongation? You make a sphere and then you have no elongation, right? A sphere would have zero elongation because it's perfectly symmetrical on all sides. If I'm right, then this explains right here why they're plasma orbs and why they're not plasma donuts or plasma hot dogs. Right there. That explains it. That's why it's a sphere, Mac. Okay. If I'm wrong, then I don't know. Give me a better explanation. There we go.
Maybe fortuitously, thank you, nature, gave us a win here, which is that how we make these in these long solenoids is naturally very, very long. And so we can build these with very long lengths. And if we can drive them fast enough and hard enough and drive the ions to move at very high velocities, we can stabilize against those instabilities and hold them stable. And so we now know we can design with a given S star over E parameter, we can design these for very long lives. The theory of the systems we make say that they should last for a few microseconds at most. Us and others in the field have been able to make them last for thousands of microseconds, thousands of times what the stability, the basic criteria would tell you. And so we know now the whole time.
So you're trying to reach 100 million degrees. How do you get to that temperature fast? And by the way, what can you say to help somebody?
So, crap, what was he saying there? Oh, so they're trying to get to this super high temperature super quickly, and spin will let us maintain our pressure. Or maintain our stability of our plasmas here, and potentially allow them to begin to self-organize. Oh yeah, what he said there is that they stay in this stable orientation 1,000 times longer than what the theory predicts. This is directly in line with Bob Grenier. Shout out to Martin Fleischmann Memorial Project. Maybe I'll have him on again soon to talk about this. Bob Grenier and Ken Shoulders, they talk about the stability of these plasmoids, self-sustaining, self-organizing plasmoids. How many podcasts did I do where I was talking about this exact concept? And now you're hearing David Kirkley talking about it, saying that we're doing this with my $5 billion company and we're going to produce fusion energy out of it. I mean, wow, we are on the cutting edge here right now.
Like me understand what 100 million degrees is like. It seems insane. What does that world look like? I guess just everything's moving really fast. Like you said, you can't put anything mechanical in there.
Yeah, so a couple of key things happen. So when gas is that hot, there's we talk about the states of matter. You have solids where
we're going to skip ahead a little bit. We understand plasma, and I don't think we're going to watch all this. I'm definitely getting copyright strikes. So if you're listening to the audio here, guys, I'm going to do my best to give you as much as I can without getting striked here. Okay, let's move ahead a little bit here to the explanation of the betas. I think this is where it is, right?
Any of the loss rates that are happening in t-tau. And in beta with B squared, you know already two of those parameters, N and T, are equal. And so that tells you right away the goal is to maximize magnetic field. Absolutely maximize magnetic field. And most folks in magnetic fusion, whether it's a tokamak or it's a DataBench or it's an FRC, are attempting to do that, maximize the magnetic field. So we're all pushing to that. What's really nice in pulse systems is that we know how to do that. In fact, in a pulse system, researchers in pulsed magnetic fields have demonstrated over 100 Tesla magnetic fields in pulsed magnets. That's much higher than you can get in a steady magnet, or what's been demonstrated so far.
So boom, right there it was. He says, the secret, because of the beta value, I explained that the beta value is the plasma pressure and the magnetic pressure. It's basically just all about maximizing magnetic field strength. He says it right there. Maximizing magnetic field strength. And we know pulsed systems can produce magnetic field strengths up to 100 Tesla. 100.
Clarification question. So maximizing magnetic field is about the N and the T, the beta. So we're not talking about tau yet.
Not yet, but we need to, because that's really important. And so we can even talk even a little bit further about how fusion scales. And so in fusion, the hotter you get the fuel, the more fusion you get. And we know that by increasing the magnetic field, B squared is in T, you increase density and temperature together. More density, more temperatures, more fusion, plus more temperatures, even more fusion. And so what we see is that in these types of systems, a scaling very clearly of magnetic field to the 3.75 power, or even in a lot of demonstrations, 3.77. That's specific.
Chat. Did you just hear what he just said? The scaling is the magnetic field to the 3.77 power. I don't know how he came up with that just now, but that's just straight up incredible. Basically, what he said is, he said, Ashton, yes, you explained it correctly to your audience. Basically, David Kirkley said, Ashton, yes, you explained it very correctly. Not only are we trying to maximize the magnetic field strength, it's actually higher than beta squared. The actual effective output that we're seeing is the magnetic field strength to the power of 3.77. So when we're talking about how does this impact fusion, as the magnetic field strength increases, the amount of fusion goes like this. Goes like this. It actually reminds me of the JANF paper, the presentation we found in the 2005 JANF paper, where they talk about the power scaling, and you can see the power scaling just go through the roof, because that's what we're talking about here. Power scaling just goes nuts. So as you increase your magnetic field strength, we're talking about getting huge amounts of fusion reactions happening. So once you see an equation like that, anybody out there that's watching should begin to wonder, why haven't we done it already? This is like, why haven't we made a pizza, guys? I've got pizza crust over here. I got some flour. I got tomato sauce. I got cheese. I got pepperoni. Why haven't we made a pizza yet? Why is the pizza not made yet? Why, we don't have any cooks in here? Just someone put it together, make the pizza. We should already have fusion. We have all the recipes here based on what he's saying. We got the physics. We got the material science. And the government's had these things for a long time. They've had this for 20 years. Yeah, we're too stoned to make the pizza. Sorry, we can't do it. All the recipes are there. All the fusion recipes are there, but we smoked too many doobs. We injected too many marijuana into our veins, and now we're too lazy. Now we're like, you know what? We could do it, but we just don't want. We don't want to. Too lazy, chat. Too lazy.
Scaling. That's a very strong scaling of fusion power output and fusion reactions. And so that tells you want to go to as maximum magnetic field as you can. Pulse systems are really powerful. Pulse systems have showed when you do pulse magnetic fields compared to a steady magnetic field, researchers have shown over 100 Tesla magnetic fields, where in a steady system, people have showed in the 20, maybe high 20 Tesla systems.
Chat, what are we talking about here, chat? Look, can you see the graphs on the screen? If you can't because you're listening on audio, the graph on the screen of Lex Friedman, the podcast, says pulsed systems 100 Tesla or higher. What the hell are we talking about here, chat? I mean, if we can do this, why aren't we doing it?
It's B to the 3.77 power. Already you can see massive fusion power outputs by doing a pulsed system.
Okay, got it. So we maximize in the magnetic field. So that's going, number go up, super up. How do you get the duration, the tau?
But then I said pulsed, and pulsed already implies shorter tau.
Yes.
And so that is, in the fusion field, the name of the game. Folks will have a very inertial fusion will have a nanosecond tau, very short, but then very high pressure. They don't have magnetic fields, but very high pressure. And then in stellarators and tokamaks, your goal is very long tau, but you'll have much lower density. And you can't really go too much in temperature, but they'll have much lower density. And so where we live in the pulsed magnetic or the magneto-inertial fusion is in the middle, is in extremely high magnetic fields, increasing pressure as much as you can, and then keeping them around long enough. And so that gets to the tau. That gets to that.
So basically, stellarators and tokamaks are a scam. Nobody will ever be able to convince me that stellarators and tokamaks are not a scam. We're not going to donut power plants. You show me any donut power plant, and I'm just going to tell you to go watch The Simpsons. Go back to Homer Simpson. Go back to your cartoons. The adults are dealing with Spheramax. We're dealing with no walls on our structures. It's like, dude, this is like so nuts to me, man. This is actually going to make me crash out. Chat, I'm actually about to crash out right now over this. These stellarators, these tokamaks, they have beta values of 5%. 5%. That means these things are extremely diffuse. They're not dense at all. So the plasma is super non-dense in these plasmas. Why did we ever think this was going to work? You're telling me we were trying an idea out with 5% beta? And we could have made one that doesn't have any walls as a 100% beta value? It's just so ridiculous that it makes me wonder, like, you're clearly hiding the secret recipe. You got the Colonel's secret recipe sauce, secret spices in the back pocket. Clearly, that's what happened here. You don't just roll out, be like, yo, just kidding. We found this new thing that's 20 times more efficient. 20 times more efficient than your current best designs. And bonus, you don't even need walls for it. There is just no way in hell that this wasn't some secret that was being kept secret by the government. It obviously was. Obviously. Really pisses me off because we're wasting money and research on these dumb, non-dense fusion reactors that are never going to be near. Like, I don't even know how you could even theoretically be as efficient as what helium fusion is talking about. Does the math work like B to the 3.77 for tokamaks? No. There's no way that tokamaks and stellarators can ever scale to the level that field reverse configuration can scale to. This is the answer right here. Now I know why. You can't scale something that's not efficient. If it's not efficient, now it needs to get really, really big for a little bit of output. But when you've scaled something the way that helium fusion is talking about it, now even something very small can produce a large amount of output. And now you can scale it very easily, and you can scale it up. He even shows here as well, I don't know if we're going to show the clip of it, but the size of ITER, ITER, the European fusion thing, it's already a scam, and it's not even built yet. I don't even think it's going to be done for like another 5 years, and it's already a scam. It's already doomed to do literally nothing. The thing is the size of like a 10-story building. Think about that. They're building this fusion reactor thing. It's like 10 stories tall. It's huge. It's huge. They have to build something that size to get an effective reactor. Lockheed Martin's over here building reactors that are the size of a basketball. Not that small, but the size of something that fits on the back of a truck. It's not, there's no contest. No contest at all. Field reverse configuration is the way to go with fusion. Anybody else going any other direction with it, I'm just saying good luck. See ya. Bye, Felicia. Bye. Go to your stellarators. Go to your Commonwealth fusion. I'm going to chill with Tri-Alpha Energy, Lockheed Martin, and helium fusion. Somebody asked about Tri-Alpha Energy. I don't know what's up with them. I don't know what's up with Tri-Alpha Energy. I think Tri-Alpha Energy might be like some government black project shit. Because why are they silent? And where are they getting their money from? How is this all working? And it's all behind the scenes. And they're putting out no products. No products. Just give us billions of dollars. No products. I mean, something doesn't add up.
Energy confinement lifetime. And also it gets to stability. And so this is the thing that this field reverse configuration, which has showed that we can build, that these plasmas can last for hundreds or thousands of times. The basic theory has shown that now you can have long enough lifetimes. So what that means is in a practical fusion system, that there are lifetimes of these high beta pulse systems between 100 microseconds and a few milliseconds, thousandths of a second. And you hold on to it for a few thousandths of a second, you do fusion, and then you exhaust it. And so the whole process in this is we start with a magnetic field that fills the full chamber. You then inject fusion fuel. You ionize it, superheating it now to an ice cold 1 million degrees, but hot enough that you have charged particles, you have plasmas. You can then start increasing the magnetic field. You form a field reverse configuration and then rapidly increase the magnetic field further, increasing from 1 to 5 to 10, 20 to even higher magnetic fields. And as you do that, the plasma heats, you compress it, increasing the field and pressure. Fusion is now happening. New charged particles are being born inside the system with a tremendous amount of heat and energy, but in charged particles. And this is where the beta really, really works in your advantage, is that just like magnetic pressure on the outside, magnetic pressure is in KT, compresses the fuel and increasing pressure and temperature. When the pressure and temperature of the plasma increase in KT increases, it pushes back on the magnetic field, increasing the magnetic field on the outside of the plasma. And what that does is magnetic field is electromagnetic current and current running in a wire. And what that does is pushes current back in the wire. And so the plasma itself now pushes back on the magnetic field, pushing electrical current out of the system and recharging the capacitors where we started this whole process.
All in a self-organizing way. So I think it's...
Yeah, I mean, it just seems so efficient. He's like, okay, we're going to cause this reaction to occur. And I think, is that how they're recouping the energy? So because everything's electric, the efficiency just goes off the scale. So you start the process and you produce this fusion reaction. You extract some of the energy from it, and it causes an expansion, which now is again just energy, just work that we can then recharge our capacitors. So it's just an extremely intelligent electrical engineering system that's using efficiency levels that are going to clearly go far over unity, in my opinion, as long as it's working as it's explained. And so far, I've seen no reason to believe that it doesn't work exactly as it's explained. The math seems to check out, and it just seems like it scales up from there. Okay, we're just going to do a couple more clips, and then we'll get to some super chats.
To clarify how fusion usually generates energy, where this intermediate step of heating up water, then the steam is the thing that leads to electricity. And then, of course, the FRC method that you use leads directly to electricity. I was wondering if you could describe sort of the difference between those two.
Yeah, I like the analogy of the match in the campfire. And I hear that a lot in fusion, where a lot of what steady fusion, think a Stellarator or a tokamak, is attempting to do is take a little bit of fuel, that match, and then add heat to ignite that match, and then put it with enough fuel and in the right conditions and hold on to it for a long time that it grows into a campfire. Even if they do a good job of bonfire, it's creating a tremendous amount of energy in that steady system, burning fuel in the same place, generating some ash, generating a lot of heat in that reaction. And in a traditional, in a tokamak or a Stellarator, that's a lot of what you're doing, is you're holding on to the heat as much as possible to keep that reaction going. And in that, the optimal fuel is called deuterium and tritium, where you have deuterium is a heavy isotope of hydrogen, where you have an extra neutron. What I think there's other ways to do it with a pulsed magnetic system. There's one more thing you get to do, because you have this high beta where there's an electric field and electromagnetic force that's now compressing the fusion fuel. It's increasing in temperature. It's getting hotter. It's increasing in temperature. Density fusion is happening. New fusion particles are being born. And those particles are not just stoking the flame. They're not just holding on the campfire like in the tokamak, but they're doing another thing, which is really powerful, which is they're pushing back on the magnetic field. They're applying a pressure. That pressure induces a current. We can extract that electrical current. But it takes you into another direction. So your analogy of the campfire now breaks down, because now the campfire is expanding. It's pushing back on something. And so now it's the analogy of the piston engine. As you move from the match to the campfire to now pistons. And so you use
boom. There it is, chat. There it is. He says, now the real analogy is it's like we created a piston. We created a fusion engine. A fusion engine. And all we're doing is feeding it hydrogen, and it is producing electricity at efficiencies well beyond any steam engine ever could. Way beyond any steam engine ever could. I see the people in the chat saying Lex Friedman must have watched Ashton. No, I don't think so. I think Lex Friedman does a lot of research ahead of time, but he's asking really good questions here that I think that only somebody who did some research could be asking these questions to fully understand the implications. I think that a lot of this goes over his head because he's like about a light year behind we are right now. But this is so huge because just like Tim Pool said when I was on Tim Pool is actually very astute. He doesn't really know all the physics and what have you, but I think he conceptually gets it. It's all about efficiency. It's all about recouping our input energy because, again, our input energy is just electricity, and we're getting electricity out. We're never converting it to heat. We're keeping everything electric. We're keeping all efficiencies everywhere as high as we can. And if we add superconducting systems to all of this, then our losses go down even more.
Piston engine, you use the motion of the piston, the pressure on it, and the motion of it to do something useful. And in a piston engine, it's to turn a crankshaft and run a turn a crankshaft and run wheels, or maybe even a piston engine to turn a crankshaft and run a generator and make electricity. And in fact, you can do it pretty high efficiency in a generator using that method, using the expansion of that piston. And what we do is use the expansion of the magnetic field to extract that electricity. And we believe you can do it much, much higher efficiencies. In fact, there's been theoretical papers that show not 30 to 35% efficiency like a steam turbine can do, but 80% efficiency, 85% efficiency. Extract much more of the energy of the fuel in that process.
Can you actually just take a tiny tangent on the word efficiency here?
Mm-hmm.
So yeah, so you said 30%. So it's inefficient. And that efficiency measure is how much of the energy is actually converted to electricity?
That measure is how much of the thermal energy that gets outside of the system is then converted into electricity, which is the thing we care about. We're not in this to make.
How funny is this? This is literally the answer to the Corridor Crew. Now, that Corridor Crew video we watched on Friday was from like a year ago. But the funniest part is the Corridor Crew guys. And the only reason I'm ragging on them is because they tried to debunk me in a really, really rude way, which history will not look kind upon them for doing. They are so dumb that they thought solar power was basically a neutronic fusion. The Corridor Crew guys thought that solar power was basically what David Kirkley is explaining right now. They thought electricity is the best, so therefore we should get solar. When they didn't realize that that's not at all what solar is or how solar works. And solar actually is, if you just were to add up all the efficiency, solar is not better than nuclear, not even remotely close. Especially when you start to take in the externalities of what it takes to build the solar panels, etc. So when it comes to real electricity production from power plants, fusion, aneutronic fusion specifically is the way to go because we're not trying to produce heat to boil water. It's already coming out in the form of electricity. Isn't this another thing where it's like, this should have been obvious to everybody? If there's a system we can produce power, electricity, and we can produce it directly to electricity as opposed to converting it from one form to another, which is inefficient, shouldn't we just be doing that? It seems super obvious to me, but I don't know.
Fusion. We're in this to make electricity, and we're using fusion to make electricity. And so from my point of view, that should be the focus, is how do we get to that? So that's the efficiency of that thermal energy that makes it out to electricity. What it is not a measure of how much energy you put into the system and what happens to that. In terms of, you started this campfire with a blowtorch. What about all that blowtorch energy? What are you getting for that? And so I think that's something that high beta is one more side benefit that it turns out is actually maybe the tail that wags the dog, is that not only do you at high efficiency get out any of the new fusion energy, which is great because that's what you want, make electricity from fusion, but you also get to recover all of that magnetic energy you put back into it. And that's the really powerful one. And that's something that folks have demonstrated over 95% efficiency, that you can put electricity into fusion and then get that electricity back out, and 95% efficiency plus some very high efficiency, maybe 80%, maybe higher, of all the fusion product electricity too. So now you're just making a tremendous amount of electricity in one of these systems.
Yeah, that now you're cheating. Now we're cheating. Now we're talking about free energy here. Now, you see what you just heard there? This is what I said at the beginning of the live stream. You guys hear what he just said there? He said, oh, somebody made a video for me. Alexander Slobsnik. Is that your username? How am I going to find you, bro? You got to tell me like what your username is on X. You want me to find you, man? He says, not only are we going to get direct energy conversion from hydrogen or whatever our fuel is to electricity at 85% or higher, we're also going to recoup the input energy at 95%. Okay, guys, just do that math in your head. We're going to put hydrogen in, and we're going to get direct energy conversion to electricity at a rate of 85% efficiency. And the energy that we put in, we're going to get that back too. This is like, you're just picking up free energy off the ground, chat. This is just collecting the rain. The rain is falling from the sky. We got the water. It's actually drinkable. We don't even have to boil it or anything. We just can use it right there. This is as close to free energy as you can really get from a conventional view of physics without invoking the ether or anything like that. Because now we're just straight up producing, and potentially now if your fusion reactions get high enough, or you get enough fusion reactions, you're just printing money. You've got a money printer now. Right? Depending on what fuel source you're using and how expensive it is. So now the problems, and this actually goes now to the next part. Now the problem is not the physics at all. The problem is not the physics at all. Because people are wondering, why are we not doing this? Now the problem is the business side of it. How do you build it? How much does it actually cost to do this stuff? And what you're going to find out here in a minute is that you can estimate the cost of a power plant by adding up all the raw materials it takes to produce. Seems pretty logical. You can estimate the cost of the power plant by adding up all the materials that it costs to produce. But there's another problem. The supply lines. You're building custom fusion reactors. They don't exactly make those parts down at the Home Depot. Right? You need specialized production of your components for your fusion reactor. Those can take up to a year to get. So now you have to build your own supply line. You got to go full Walmart here. You got to go vertical integration, chat. Look at me with my business terms. You got to get vertically integrated, and you got to start producing your own stuff. Why is this big? Who is the other? What's the other big company that's doing compact fusion reactors? Lockheed Martin. This is exactly what Lockheed Martin is doing. Remember, what did Charles Chase say on his resume that he probably should have deleted? By the way, Charles Chase, I love you. You're my GOAT. You'll always be my GOAT, Charles Chase. But boy, oh boy, I bet you the CIA came and knocked on your door about your resume. Really shouldn't have said that you were the one that convinced the Lockheed Martin CXOs to do the compact fusion reactor and that it's successful and breathing on its own. Because Lockheed Martin figured out, oh, we can make this small compact fusion reactor. What did they do with it? They added it to their production line. Basically, Charles Chase, if you're imagining like a video game, we're playing a Dungeons and Dragons game here. Charles Chase just handed them the sword of 1,000 truths, chat. The sword of 1,000 truths. Can we trust this to a noob? I don't think we can trust it to a noob, chat. So Charles Chase rolls up. I'm bringing it down for your guys' level so you can understand. Charles Chase rolls up. Lockheed Martin's struggling. They can't beat the raid boss, chat. Lockheed Martin can't beat the raid boss. Charles Chase rolls up. He's like, guys, I've got the answer. The sword of 1,000 truths. Here it is. A neutronic compact fusion reactor. It's modular. We can make it. We can put it on airplanes. We can build energy reactors out of it. And by the way, it's tiny. It's only the size of like an engine. It's small. He rolls up. Now Charles Chase is the hero. Now the raid boss had no chance. They basically got hacks, chat. They got the Thunder Fury, and they shouldn't even have had the Thunder Fury yet. Only my WoW players are going to know that reference. So they destroyed the raid boss. Destroyed him. The problem is it was too good. Nobody else can have the sword of 1,000 truths, chat. It's too powerful. Too powerful for a noob to ever have that power. So what happened? It went dark. It went dark. The GMs, the game masters stepped in. Blizzard came in, chat. They came in, they said, you can't have that weapon. It's too powerful for a noob. And they took it. They said, this is going dark. Only U.S. government black projects are allowed to use the sword of 1,000 truths. But it's now been added. in the classified catalog of components that you can add to your ship, right? I'm building my custom ship. There it is. Compact fusion reactor. What kind of engine do you want in your new custom model? I think we'll have one of these. Throw this in there. Add that slot in there. Boom. There it is, chat. That was your Ashton story time. Okay, let's skip ahead a little bit. Now that I explained that, here's David Kirkley. I think this part is him explaining it.
That's the kinds of teams we try to build at Helion, is folks that want to really get their hands dirty.
So I have to ask then, what timeline do you think? Like first working out their nuclear fusion power plant. When do you think?
Yeah. So what we've been able to do is rapidly build every few years, bring a new fusion system online. In 2023, we signed a deal with Microsoft to build a power plant for Microsoft for one of their data centers. And this is a power plant that is plugged into the grid, generating electricity from fusion. And with a very, very tough, ambitious timeline of 2028 for the first electrons from that power plant.
And that power plant will be powering. This is a pipe dream. Like this is
crap.
This is indeed impossible. Then you wake up the next day and you're like, all right, we're going to do it anyway.
I mean, that's the thought process. That's the mentality. We're going to do it anyway. Let's go do it. The world needs it.
I think it's
there's no physics reason this can't be done. Now it's a question of how fast can you build it? And can you engineer it to be as efficient as it needs to be? And those are engineering and manufacturing are ridiculously hard challenges. So do not short sell that. But that's the goal. And that's what we get up every day thinking about. This is something I was actually just thinking about and talking with some of my team in the last few days. We certainly have people that say like, no, this can never be done. And we had that before. We had that at the very beginning of, I want to go merge these plasmas together. And folks said, nope, that can never happen. And we went off and did it. And you can't compress an FRC because it's unstable. In fact, I actually still hear that. FRCs are unstable. And I say, yes, I know. Now let me introduce you to S-star over E and 20 years of studies on what we know about that and how we...
So I was dragging through this because there's a few slides that show up on here. He talks about the contract with Microsoft. And he says something here that I did not know, guys. And now I'm even more on Helion. He said Microsoft was there when they were testing all their reactors. So Microsoft didn't get involved just a couple of years ago. Microsoft has been watching Helion as they've been iterating through their reactors. Oh, wait, did I take a screenshot of it? I think I took a screenshot. Let me see if I can find it here. Oh, it's not. Yeah. Oh, I did take it. Okay. I'm going to pull up this screenshot because I was looking for it and I can't find the screenshot in there. That's why I took the screenshot, because I had a feeling I was not going to be able to find this later. So here you go. Let me share this with you guys real quick. Here. Okay. How do we make this smaller? There we go. This is actually Helion Fusion's timeline right here, guys. Take a look at this. Prototype number 1 through 3 was between 2005 and 2012. Early experiments, deuterium fusion. They were shooting plasmoids at each other at 300 kilometers per second. That's what they were doing in their first iteration. That is almost identical to what the Marauder program was doing in the 90s, shooting plasmoids at each other with the U.S. government. Almost identical. Just 10 years later, basically. The Marauder program was, I think, 1992 through like 1995. So we've actually found all the projects, including NASA Breakthrough Physics Propulsion, all these government-connected projects that were working on these similar technologies, space-time manipulation, etc. But look at the magnetic field strengths here, guys. The Grande, 2014, 4 Tesla. Okay, this is only 4 Tesla. That's nothing. Look at the Venti, 7 Tesla. That's only 7 Tesla. Look at the Trenta. This is only 5 years ago. The 6th prototype, 100 million degrees Celsius. That's only 8 Tesla compression. This is why Helion Fusion is worth $5 billion. Just look at that right there. Look at the trend. Look at that trend since 2020. They already achieved 100 million degrees at 2020 with just 8 Tesla. That's all it took, 8 Tesla. And so now they don't even say. They say Polaris, 7th prototype, direct energy conversion goal, 25% larger than Trenta. Come on, chat. They're definitely going to be hitting fusion with this one. Polaris is definitely hitting fusion threshold. They were already well above it beforehand. And so now, as their next one, and then beyond this, they're probably going to be producing energy that's going to be going on the grid. And that's their goal, by 2028, to have energy on the grid. in 2028. Fusion, aneutronic fusion energy on the grid 2028. That's only 3 years from now. So what I'll say is this, guys. This is not stock advice, but this company, I don't see any way this company fails. The math, everything right there works out. They've got multiple prototypes. Microsoft has been working with them while they've been working through these prototypes. So if anything was wrong, you know Microsoft is doing their due diligence. They're doing their due diligence, make sure it all works out. And they shouldn't have this much. They shouldn't have this much funding and this much backing. Like, how have you already gone through 8 different fusion reactors and people are still throwing money at you, but you haven't ever sold anything? Because they know that the concept is going to work. They already know it's going to work. Okay. One more thing. Okay, yes, here's one more thing, and then we're going to do our moment of Zen for tonight, guys. Let's skip ahead to like about here. Oh, hold on. What the hell? What did I just do, chat? Sorry, I stopped sharing. Here we go.
A couple of things. So one, to get access to it, we have windows. We have small windows all the way around that we look into it with cameras, spectroscopy, lasers, other kinds of scientific diagnostics that we use to measure. And so you see the light emission through that, but also it's very bright. And so the actual vacuum vessels themselves that we use are ceramic. There are some versions of silicon and oxygen, typically quartz, but there's also some other sintered materials. And it's so bright that they can shine through those materials. And so what you see is you see the light of, not fusion. When fusion's happening, thermonuclear fusion is so hot that the light is in the X-ray spectrum, and human eye can't see that. But as you're that ice cold 1 million degree plasma, when you're just getting started.
Boom, chat. OMG. Were you listening right there? What did he just say? The human eye cannot see it when the fusion reactions are happening. Why? Because it's releasing X-rays. It's releasing X-rays. Chat, why are they recording? Why are they recording in thermal in the MH370 drone video? Partially because it's nighttime. Partially because it's nighttime. Why is this video in thermal? You wouldn't be able to see the lines coming in front of the orbs. If we were looking at the orbs in this video, I'm going to show it bigger here. If we were looking at these orbs with our own eyes, it would just look like a plasma ball. You wouldn't even see the X-rays coming out behind it or in front of it. The dark lines are dark because it's not in the optical spectrum. Because we're literally looking at a fusion reactor spitting X-rays out. And so the reason why they're recording in this thermal IR is because they know exactly what they're looking at. They know exactly what they're looking at, and they know what to expect. They know what to expect. And that's why they're zooming in on this. Look at those plasma orbs. What, are you kidding me? You can see the skin of the plasma orb like pretty clearly. And then they change, they reconfigure right near the end. They reconfigure and then they collapse. Boom. Yeah, no doubt. No doubt. Nuclear weapon. That's a nuclear weapon. How you define nuclear weapon? Like, nuclear weapons are about to get a lot more confusing, chat. Nuclear weapons are about to get a lot more confusing. It used to be really simple. Nuclear weapons, a big boom. Big boom, you got a nuclear weapon. Now we're going to be like, we got floaty plasma orbs that are doing shit. We got space-time manipulation. We're compressing things into black holes. We have neutron bombs if we just want to irradiate you to death. We basically have like it's basically like Burger King, chat. You get to have it your way. You get to have it your way. If you are a deep state military contractor that likes to zap airplanes, we got everything for you. We got everything. You want to teleport it to the next dimension? You want to teleport that shit to the moon? We got you. We got you covered. You want to melt those people so their skin falls off? We got some of that, no doubt. You want to just fry their brains so that their body just falls over limp, like the Tesla death ray? I'm sure we got that too. We got everything. Have it your way, chat. Have it your way. Okay. That was the last thing I wanted to show. Okay, I'm going to do the super chats here. As I do the super chats, I have one more. I want to talk politics for just one brief second. I'm going to shit on Nick Fuentes for a second because we're frenemies. We're frenemies. He's never talked to me before, but we're frenemies. And I have to say that everybody was saying that MAGA was dead. They're going, MAGA is dead. Ooh, we're all Israel schizos now, and we all hate the Jews, blah, 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 right? And they were shitting on Trump, and now Trump is just literally just destroying MTG. I call her MTGG. Majorie Trader Green. MTGG, because she's cooked, chat. She's cooked. Trump is just annihilating her on social media. And Massey, he went after Massey's wife. Remember, Massey's wife died and he got remarried, and it was only like a year ago that his wife of 30 years died. Trump was going after her too. So all of the libertarians and all of the woke right have been saying, MAGA is dead. Trump is so mean. And then this is the best part. I want to point out, I was right about Nick Fuentes. He just wants a friend, chat. Nick Fuentes just wants a hug. That's what he wants. That he's just spiteful and he's angry. And all he needs, all these Groyper people need, is just to give him a hug and say, it's going to be okay. It's going to be okay. Because here you go. Trump gets asked. So literally like one day ago, Nick Fuentes is saying, MAGA is dead. It's all over. You guys got fell for it again award, right? Take off your hats and put on your new Democrat hats, right? And then Trump gets asked about Tucker Carlson and Nick Fuentes. And he doesn't shit on them. He's pretty respectful. And he's like, Tucker can talk to whoever he wants to talk to. They can have those conversations. What does Nick do? I couldn't avoid this. I had to talk about it. Nick posts, thank you, Mr. President. Thank you so much. And I'm just sitting here laughing my ass off because it's like, dude, one day ago, you were saying that MAGA is over and the administration is dead. And then the moment that Trump, he didn't even praise him. He just didn't shit on him. He's sitting there going, thank you, sir. Thank you. Could I have another, please, sir? I'm just like, oh my God, are you kidding me? Are you kidding me, chat? It really is. He just needs a hug. It's really all it boils down to. He just wants to be accepted. He just wants somebody to acknowledge him. I love it, chat. I love it. Okay. I still like you, Nick. I have nothing against him. I think that Nick will be great when he grows up out of this weird conspiracy Israel shit that he's doing, because he's smart and he realizes how people are going to use the stuff he says against him. He realizes this stuff. He's just decided that he's a one-issue person, and that one issue is one that's just like way too far out there for a lot of people. So I don't know. I wish him the best. Okay, guys, let's do the super chats. I'm going to start with the pilled super chats because you guys were popping off in the pilled chat today, guys. Thank you. And hey, everybody in the pilled chat. Matt1776 gifts a cookie. Nom, nom, nom. Delicious cookie. When will we get the government to acknowledge MH370? I will say that I did have private correspondence. I probably shouldn't have actually, by the way, posted those emails with Charles Chase and Hal Puthoff. And I understand that. But the reason why I did it is because those guys are never going to talk to me again anyway. They're probably never going to talk to me again anyway. I did have private correspondence with another OG MH370 investigator. I'm not going to say who. They're not necessarily in agreement with us, but I said, hey, I don't care if you agree with me or not. I really don't care. I already know the videos are real. What do I care if you agree or if you believe? Just don't be afraid to speak about the videos. The only way they can cover this stuff up is if people won't talk about it. The more people talk about it, like I literally told them, if you want the truth of MH370 to come out, talk about the videos. Even if you say, hey, they're super fake, because that will force the government to say anything, say something about the videos. They don't want to say anything about the videos because they can't lie publicly. They're going to get caught in a lie. They're going to get caught in a lie. Those videos are real. It's Gorgon stare, wide area motion imagery. Nobody faked that. Nobody faked that. No chance. And we're literally reviewing the physics now on a daily basis that is emerging only now, 10 years after that happened, which is perfectly in alignment with what the military technology would be ahead of the public. Okay. Thank you, Matt, for that. Appreciate you, brother. Thank you, guy whose name I can't say. Appreciate you. John Glock also says, something is needed to generate topological monopole inside of the orb. Yes. In the case of MH370, fractal chortle moment. Let me add to that. Remember the equation that he showed? The equation he showed had another parameter in it. It was not just the pressure is equal to the magnetic field strength squared. There was a denominator. The denominator was divided by 2 times the magnetic permeability of free space. That's interesting. So look at the magnetic pressure equation again. What if we change the permittivity of free space? What if we change the permittivity and permeability of free space? If the permeability of free space changes, now that causes the denominator to go towards 0. That means the numerator skyrockets as well. So there's your answer right there, is that there's 2 amplification factors at play. One amplification factor is simply the magnetic field strength. We want to maximize the magnetic field strength. The second amplification factor is a little bit hidden. If you can reduce the permeability of free space, you also get an amplification factor of your pressure. This is what speaks directly to this idea of creating a topological monopole, creating a little black hole at the middle of our orb that basically has fusion going on at it. Because we manipulate space-time itself to actually amplify the pressure effect. There you go. That, I think, is why we don't even have to change the math. The equations work. You just have to realize that the permeability of free space is not a constant. It actually can be changed, can be manipulated. Great question there. Then John Glock says, and once again, I'm probably going to try to talk to Bob Greener. Says Bob Greener, others have produced 1K Tesla magnetic field strengths. So yes, there have been arguments about producing these really high magnetic field strengths, but it's a matter of how much credibility there is aligned with that. Thank you, Methel, for that. I appreciate you, brother. And then John Glock, speaking of hiding the recipe, I finally watched Hal Puthoff on Rogan, and wow, incredible gaslighting. We just don't have the physics, he says. Bullshit. 5 minutes on plasma and 0 point energy, almost 3 hours. So glad I listened to the real Hal first before the Rogan cover-up. Yes, if you just watched the Hal Puthoff interview on Joe Rogan, we were pointing that out when it first happened, was how, like, he's talking about remote viewing and all this stuff for like 2 hours and then like 5 minutes on 0 point energy. And it goes to show that it's kind of being allowed to drip out. Hal Puthoff knows the MH370 videos are real. No question. All of the engineers that were working on this, all the engineers that wrote the DIRDs, they know the MH370 videos are real. No question. Every single one of them knows. I even think people like Larry Forsley might know. Anybody that understands nuclear reactions, nuclear physics, they're going to be looking at those videos going, that's a nuke. That's a nuke. There's very telltale signs that nuclear physics is in action. One of them is geometrical shapes and plasma orbs. Okay, so thank you for those donations. Filter Dog gifts the cookie. Says, keep pounding. Thank you very much, Filter Dog. Okay. Also, I just want to shout out the Rumble chat. I don't think I have donations set up on the Rumble chat, but thank you very much, guys. I appreciate you all. And then we got some super chats here as well. Chaotic good. Lex Friedman stole James Lipton's pentameter. Yeah. I actually don't have anything against Lex Friedman. In fact, back in the day, I was trying to simp to Lex Friedman because I thought he was such an intellectual. And just the reality is he's just fallen far behind, like super far behind. I mean, he was an intellectual. 2 years ago, I had no chance against Lex Friedman. He would have been an intellectual powerhouse that I could never even have maintained a conversation with. Now, Lex Friedman can't even maintain a conversation with me anymore. He can't keep up anymore. I mean, he's struggling with concepts related to aneutronic fusion that we figured out like a year ago. So it is what it is, chat. I really don't care anymore at this point. I'm in full IDGAF mode. Fly Ether. Nice to see you, brother. Hope you got some good clips out of tonight. Micro reactor for the military, but not for the people. Exactly. I mean, nuclear micro reactors for the government, like, people should be wondering a little bit more about what the hell a nuclear microreactor is. And if we can build nuclear microreactors, how come we have nuclear power plants that are like huge and huge liabilities as well? Just something to think about, guys. Just something to think about. Zapparoo says, fantastic. Thank you for that huge donation, Zapparoo. Fantastic. This is the real disclosure. Ashton, you're running a graduate course in both physics and investigative research. You've more than earned your PhD Hawaiian shirt. I forgot to mention the Hawaiian shirt, chat. I can't get over the Hawaiian shirt. I'm watching it and I'm like, what is this? Breaking Bad? This guy is, why is he wearing Hawaiian shirts? You will never catch me in a Hawaiian shirt. Not ever. Literally never. Even if I'm at the beach, I'm still not wearing a Hawaiian shirt. It's just not in my, there's 0 Hawaiian shirts in my wardrobe. None. Not even one. I don't know what it is, but whatever. If he's rocking it, he's working it. I appreciate it. If you are like a soon-to-be billionaire, which David Kirkley is definitely about to be, wear whatever the hell you want, bro. Wear whatever makes you comfortable, my douche. Wear whatever makes you comfortable. Reminds me of the Facebook movie where Jesse Eisenberg's character is just wearing the robe. He goes to his investment meeting, which just the venture capital meeting with just a robe on because he knows he's worth so much. Timothy Foster, thank you for that donation. Thank you for teaching. Thank you for listening. Appreciate you. And then this one, I don't know. I'm going to write your name down because I can't remember how to find your thing, but we'll take a look, man. Alexander Slobnik. Thank you, man. Are you the guy that does the scientific paper? If so, I think I already watched it. If it was the AI thing, I think I watched it, which was good. Thank you. Appreciate it. Okay. Our moment of Zen tonight, guys. And I'll just look to see if there's any other questions in the chat. You guys had some good questions. Oh, the other thing people are bringing up is something about some drilling James thing or something. It's probably a scam, guys. Don't get caught up in all these weird, like, remember that guy who had the alien fungus or whatever? Like, you're getting caught up in weird TikTok shit, chat. Don't get caught up in weird TikTok shit. Focus on the science. Focus on what we know is real from the science. Don't get caught up in clickbait and bat boy stuff and people that are trying to get you to follow into their new alien trend, right? 99% chance is a scam. 99% chance. Okay. Our moment of Zen. Where is it? Oh, it's already up here. The end of this. So Lex Friedman does ask some pretty good questions here, guys.
It's emitting.
And at the end, he asked about the Fermi paradox. So, of course, Lex talks for like 3 minutes here. The Fermi paradox is this idea of why don't we see aliens out there? When we look out of the sky, how come I don't see alien civilizations everywhere? There's a couple theories on it. Dark forest theory. Everybody's too afraid. Maybe there's nobody out there at all. That's the reason why we don't see it. But that's not, I think all of those are regressive views, right? I think we do see them out there. We're just not looking for the right thing. I think that aliens are so technologically advanced that we're just not seeing them. The same way where we don't look like, imagine Native Americans looking for signals of other people, and they're looking for smoke signals because that's how the Native Americans were using smoke signals to communicate. So they're looking for smoke signals. But we're using electromagnetic waves. They're never going to see our communications because we're communicating on something that's invisible. The same idea holds true for the aliens. They're communicating through the ether. They're using quantum entanglement to communicate. We're not even detecting it. In fact, we are detecting their communications. We're just not looking for them. We're not looking for them, therefore we don't see them. We also, if we looked using high-frequency gravitational wave detectors, high frequency, I think we would see warp drives flying around in the sky. In fact, I think that some of either the fast radio bursts or the gamma ray bursts, some of the stuff that we're seeing out there is probably actually technosignatures, and we don't even realize it. We don't even realize it. So now that being said, let's listen to what David Kirkley's view is of the universe. Because the reality of this is what I want to know. Does David Kirkley know about this? How much does David Kirkley really know? Does he know that we figured this out from fusion bombs? Does he know that we can potentially produce free energy? Does he know that this has been suppressed? Does he know the implications of this? Or is he a regressive thinker that thinks, nope, whatever, that we're not seeing the aliens, they don't exist, blah, blah, blah. There's no, we've hit the peak of technology. Now, my guess from just listening to this today is that he's got to be a little bit enlightened. So let's see.
Do you think it's like pretty certain that they, in order to expand out into the cosmos, they would be using nuclear fusion?
It's hard to imagine anything else. That right now, where does energy in the universe come from? And it comes from fusion. It comes from stars. And we know that that's the process. And
what's the power source, chat? A+, actually S tier, A+ answer right there. What is the power source for the aliens? Do you think they're using nuclear fusion? No question. That's what he says. Power source of the UFOs is nuclear fusion. Neutronic fusion is what's powering aliens, chat. Right there. That wasn't even the Yahtzee, but that's just a bonus.
So whether they're harnessing the star itself, Kardashev Type 2, or are they bringing fusion along because they want to go somewhere and they're bringing it with them to go visit? I think that's pretty That's pretty likely. You bring up the Fermi paradox.
Mhm.
How come we don't see alien civilizations? Even if it's infinitesimally small chance that there is life on any one planet, and infinitesimally small that life grows into intelligent life, there are, however, almost infinite planets around infinite stars in our galaxy that have been around for vastly longer than we've been around, but we don't see it. And I think that's a question that many scientists and everyone has wrestled with over the years.
I mean, I'm very scared by the implications of that. The scary thing is that, to the point that we made earlier, as we become more and more technologically advanced, we end up destroying ourselves. Like, there could be things we unlock, like nuclear weapons, but plus. Like,
there you go. That's probably the real reason why Lex Friedman didn't talk to me. He can make up whatever answer he wants right there. The answer is most of the aliens are probably destroying themselves. Right? Where does this technology lead? You eventually make a weapon that's so powerful that any individual can destroy the whole planet. How does any civilization survive that? The only way you could survive it is you all spread out. We all just spread out. Maybe we reset ourselves. So there you go. I'm going to let him keep going.
New things that happen as you develop super advanced systems that close to 100% probability destroy ourselves, destroy any intelligent being. The kind of intelligent being that's ambitious enough to keep innovating will eventually destroy itself, will be one explanation. And that's scary. That should be a sobering, that's at least an inspiring, sobering thought, to be careful with the stuff we create. But I also just looking at humans. We create dangerous stuff and then figure out, like, sometimes almost like last minute, how to not destroy ourselves. We're good with deadlines.
We're good with deadlines.
And we're good at, like, surviving. I mean, life as we know it on Earth seems to find a way. And intelligent life as we know it, human life, seems to find a way. We do a lot of painful things along the way, but in the end, we somehow survive. It's interesting. There's something in the human spirit.
I think I agree with Lex to a degree. We've survived this long, but we didn't have the kind of weapons we're about to have. The kind of weapons we're about to have make our current weapons look completely obsolete. They make them look like the same. It's the same as the conquerors, the West showing up against the Native Americans with guns when they're using bows and arrows. Just no contest.
That allows us to survive. So I have, like, a lot of optimism about the super powerful technologies that we create will eventually lead to us still surviving for thousands of years. But then, like, why are the aliens not here, though? So maybe it's also possible that it's really difficult to traverse space. Maybe it really is that difficult. The physics makes it not easy. There's a lot of space.
It's not.
It's just hard to travel.
I think
it's easy. It's not hard.
As I have gone further and further in building fusion systems that work, I've become more optimistic around the Fermi paradox specifically. And there's several of them, but I think you're referring to something called the Great Filter. Something happens that filters out life. The dark forest is another philosophy around, sure, it's out there, but everybody's hiding because they don't want to be noticed. But I think about something else, actually. The philosophy that I've always loved, and I'm going to pronounce this wrong, so I apologize, Matryoshka brains, is that, and that's Kardashev level 2, that civilizations get so advanced and they focus not on expanding physically and expanding in space and expanding their reach by planting flags in new places, but grow their cognition, grow their ability to think. They grow their brain, they grow their intellect. And I feel like in the last few years, we've seen a massive trend that maybe this is the thing that happens, and that we do grow our intellect, and we grow the intellect of the species by AI and advanced tools, and as a society can just get smart enough that we don't need to go plant those flags everywhere. And so the Matryoshka brain is a Dyson sphere where a civilization has covered the entire sun in essentially solar panels, or collects its light in some way and uses all of that power to power intelligence, to power computers, and to power brains. And I think we're a ways away from that, but maybe AI and fusion together gets you actually along that path sooner. And
wow. Well, chat, that was your stream and that was your moment of Zen. What did he say right there then? Maybe AI and fusion gets us there faster. I think that couldn't be more accurate. And his perspective is, I think that you're going to have so much energy. His perspective is essentially, you're going to have so much energy that you're going to not even focus on expansion. You're just going to focus on self-improvement. You're going to have so much energy at your fingertips, so much computing power that you don't care about expansion. Why would we care about that? This is where people talk about where it's like, why would I bother going to another star, another planet? We have everything we need on this planet, and we don't even need the star. We don't even need the star. We can make our own stars. There you guys go. That's your moment of Zen. That's your message of optimism. I hope you guys enjoyed the live stream tonight. The answer is fusion, neutronic fusion. That's what the aliens are using. That's what we're going to use for the next 1,000 years. unlimited energy of fusion, enough hydrogen to last us 100 million years or longer. And if we're right about the ether and 0-point energy, then we have an unlimited reservoir where we can literally pull hydrogen out of the ether to use as fuel. Have a great night, everybody. Thank you, MH370X. I love you guys. Peace out, everyone. Later.
In the fields where the skies are wide, talking about a journey through the cosmic ride. Einstein and Thorne, they set the stage for a trip through time across the space age. Wormholes connect distant points in space, traversable paths to a far-off place. No black holes pull, no crushing weight, just a cosmic tunnel to a distant gate.
Talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Bowling 777 through a wormhole flow. We're talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Bowling 777 through a wormhole flow.
Exotic matter, negative energy's the key to stabilize the wormhole for you and me. Quantum vacuum squeezed so tight, creating conditions for this wondrous flight. Static fields and lasers in the lab they play, generating forces in a new kind of way. Gravitational squeezing, Casimir's force, negative zones we need to stay the course.
Talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Bowling 777 through a wormhole flow.
Thin shell formalism, plates so fine, spherical geometry we realign. Energy conditions that we must defy. For a stable wormhole, let's give it a try. Coulomb forces balancing the plate, creating the throat, open the gates, from Earth to the stars in a single bound. A shortcut through space profound. Engineers and dreamers hold the key to future worlds and what we could be. With science in hand, we forge ahead through the cosmic paths that we now tread.
We're talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Boeing 777 through a wormhole flow.
From the fields to the stars, we break the chains. Understanding the universe, we make the gains. Lil Hula Crunk shines, bringing truth to light. Through his music, we'll explore the night with wormholes and